Delicate so.
Oh yeah, it's a big deal. We have season tickets. Yeah.
Yes.
Oh, it is.
Baseball games are fun too.
Yeah. Yeah, the soccer team is just fun. The crowd is wild. It's just a
No.
yeah.
Northwest corner.
They won. So we've been, our son plays soccer. So we've been, indoctrinated.
Yeah.
Yeah. There's a, I think about that. Huge soccer.
Yeah, and this is the nice thing about
Here's what.
I don't like the stick figure.
That's that's where all the pucks are on Saturday. So every Saturday we go out and yeah, there's someone on that side.
Okay.
And it's fun to just go out there and just, you could just, pull up to anything. No microphone.
You can just hear it. Can you hear it? Can you hear me? Testing, 1, 2, 3. Testing, 1, 2, 3. Like this. Good. Okay. Good morning, everybody. Thank you for that. Hey. Thank you for all helping us to convene into a Navajo Nation Council Health and Education and Human Services Committee work session for May 18th, 2021. With that, the main purpose was to hear a presentation by UNM Metals Research Team. So, we basically have, we're going to incorporate both agendas into one. So that we'll see with that. Okay, with that, let me call this work session to order. Change to roll call, please.
Is there Honorable Paul K. Jr.?
Dr. Paul Gates present.
Honorable Carl Russell Slater? Paul Russell Slater? Honorable Bernal Alona? Honorable Bernal Alona? Honorable Charlene So?
Charlene.
Present.
You? Honorable Daniel D. So?
I'm here.
Honorable Mr. David
Here.
Chair, 4 members, constitute quorum.
Thank you. Thank you, Mr. Mose, for the roll call. And then at this time, I'd like to call on my most revered older brother, Dr. David Gay, to provide the invocation for us. Citizen Chief. I want to greet everybody. Good morning this morning. I want to sing a song that has to do with leadership. Not on the beginning. This song goes way back in history, several hundred years old. And the key word in that is nanta. Nanta has everything to do with planning, communicating with one another, and using the energies that's out there to communicate, the air to communicate, the environment, the mountain, the energy from there to communicate, the sunlight to communicate, the different trees, plants to communicate. In the midst of all of that communicating, so this goes back to pre-Albuquerque, this song, very old, before the coming of the Spanish people to this part of the country. After Mexico gained independence, this song existed back then. And people were planning, communicating with one another and talking about things, discussing things and listening. So I'll sing that song have a corn pollen bag that we use. A lot of the people, they use these corn pollen bags and they praising, they acknowledge, the creator. Oh, nana, oh, yeah, yeah, oh, nana, mama, yeah, yeah, oh, nana, Ashki, Nedeko, Nanet, Nana, yeah, Hayas Kasia, Apeta Haslako, Nanet, Nana, yeah, Tanskaya, Apeta Haslako, Nanet, Nana, yeah, Yote Ikase. Apeta Haslako, Nanet, Nana, yeah, Tu, Tanashindi, Apeta Haslako, Namet, Nana, yeah, Tatenia. Apeta Haslako, Namet, Nana, yeah, Tashiana, way, Abiga Hojon. Leluko, Nanet, Nana, yeah, Petre Hojonko, Nanet, Nana, yeah, Pekisha Hojonko, Nanet, Nana, yeah. Oh, Nanet, oh, yeah, oh, Nanet, yeah, oh. Naya nata soi ati nedne nanetang yaya no ho sui apeta hazlako nanetang yaya so yeah apeta hazlako nanetang yaya this is the sasaya apeta hazlako nanetang yaya tobi ajiye Apeta Hazlaka, Nanetang, yeah, Trapitin, Apeta Hazlaka, Nanetang, yeah, Nasan away, Abike Hojone, Nedlenko, Nanetang, yeah, Bekishta Hojonko, Nanetang, yeah, Bechiche Hojonko, Nanetang, yeah, Beyaki Hojonko, Nanetang, yeah. Betiki Hojonko, Nanetang, yeah. Venate, son Hojonko, Nanetang, yeah, Trapitin, Ezate Hojonko, Nanetang, yeah. Oh, Naneto, oh, yeah, oh, Nanetang, yeah. Oh, Nanetang, Hojonko, Stephen Chopai, again, you teaching is one dog, Nathan Dean, baby, is one jungle. Other than she, John, Beijing, but I don't know, the DK, I don't know how to see those, so DK, about Fahrenheit. I don't know, KI, she, yeah, she does it. That is a city for the whole environmental health, just on how it affects the earth. He could now if I find that other things the pieces of some of the scientific knowledge and simplifying it for a presentation so people, the community people can also learn from this experience and presentation. Kot ila digin jo pa iyo masajin pa ode o ila unit na khacho pa da indicating that so yo in see case so indicated in khacho pa kot ila jo pa jo na singo 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 Thank you. Let's see. Donde Daniki, and A to Kodesh, and Peace. Including so is table. Okay, committee members. So introduce ourselves. We'll focus in the room and focus on the call.
Good morning. Good morning to you all. My name is Paul Figueroa, a delegate from the northwest corner of the Navajo Nation. I represent 5 chapters. The tree sitting right next to Lake Powell, Page, Arizona. Caught the Mine, my voting chapter. Waterway Gap, located on Highway 89 between Flagstaff and Page. Hybito and Tonalea. They're on the east side of Page. So I am of the Gap and the Rock clan, born for Deer Springs. My maternal grandfather, they are of the Bitterwater clan, and my maternal grandfather, paternal grandfather, they are of the Towering House clan. So this is the way we introduce ourselves in the Navajo way. Long ago, name was irrelevant. We didn't have a name, so your identification was based on your clanship system. 4 clans, your mother's clan, your father's clan, your maternal grandfather, and your paternal grandfather. And they're all different clans. And that way, you are related to other Navajo people. It don't matter if I'm from the west corner of the nation, I can go over to the east side where Honorable Delegate Daniel Sobey's from. I learned that he's my chief because his paternal grandfather or maternal grandfather is the same clan as I am. So in that way, he's my grandfather, my grandchild, and that's how we greet each other. So it don't matter if you don't know the person, we're related in some way. Just a little lesson in clanship system, how we greet ourselves. Thank you. I appreciate the long journey, 7 hours, but I'm happy to be here. Have a good day. Thank you.
Yate, SMJ Unica. I represent 2 chapters, Springs and St. Michael's. Tito Toso. Ado Slinike she's not a pampas is cheap, Kiani is cheap, cheap. Happy to be here this morning. Get information that benefit every one of us. Thank you.
Oh, yeah, 8. Good morning. Glad to be here. For us, the committee, this particular sitting committee, this would be either the 2nd or the 3rd time we've listened to the research group. We really appreciate and embrace the work of the community folks, because they are the most heavily affected. We hear about being front line, being in front line. So, got 8 Kados of the man, the Jays and Daniel Service, Nico, Santa Kinem, Sean, as a Kachin, Buses Chin, Christian, this is Chin, no, Ronnie, the son. I represent
and stand guard on the east side of the Navajo Nation. The district I represent includes Counselor Chapman. Chapter houses north of 5. Then coming south, Encino, Torreon, Scarlet, Lupentado, Pipers Lake, Little Water, Casimiro Lake, and Vaca Pruitt. Vaca Pruitt chapter house is south of I-40. So the district is more than 180 miles long. The reason I represent 8 chapters is because we have the least population. Honolulu and acre represents 2 chapters that equals the 8 chapter population that I represent. We're pushing in that manner. We appreciate everybody being here and the folks that are on the call. Welcome to our work session. We have Honorable Charlene Stowe on the call. If she could put her on.
Oh, Yad Eben. Thank you, Shiaj. That's enough again to the people there. Good morning. Shija A. Charlene. So, I don't want to come back Nasha. Nash Ejan don't drop on so, but any bushes shin to chitney dash check, chitney dash nalle. I don't banash, she get a anis a sandajin. I don't know, a Mexican water. I don't see a red mesa. Isosbus, I don't hold a can sweet water. I could ocean and log the at the Nebana Shaggy. I got a hand in the dish. Good morning.
And we have Honorable Closely, Honorable Pernell Helena on the call.
No. Nope.
We're multitasking this morning. We have a leadership meeting with convened by the Speaker of the Council, Seth Damon. Earlier, you heard from the speaker, you heard some of the proceedings. So, however, we are here at the invitation of Dr. Johnny Lewis to hear the most recent work. At this point, if we could have people introduce themselves.
Good morning, I'm Dr. Deborah McKenzie. I'm the Executive Director of the Community Environmental Programs directed by John Lewis. And I will be updating you on a couple of our projects today, and I look forward to sharing more information.
Good morning, everyone. I'm Dr. Sarah Wilson, and I'm new here to UNM. Started in January, and I've been working with the METAS team, and just very happy to be here today. Thank you.
Good morning, Dr. I work here at UNM with the metals team. I do research on metals interaction coding. And how they tend to make it up by
Hi, my name is Don Godwin. I'm the Dean of the College of Pharmacy. And again, I want to welcome everyone here to the Health Sciences Center. I look forward to today's meeting.
Can you hear me? I don't know how to work this thing. Shaya, Sarah, he or Adakine, she know, Shishinaskale, and English. Ado Kubasna, I mean, Bashin, Kiani, the Shanala to the tea in the Shin. Yeah, she should say, those and I, those as they did. Ado, I guess in a shadow, a day, children about them. She's not a boy, yeah, are they, is she knows that the end of the other kid. Ado, Craggy, University of New Mexico, Johnny Lewis, yeah, a presentation show, 2005. Ado, Science Research, AICID, but our area, the community, the algebra community vision is I'm just saying, though, and then not I say,
Şeyden şimdi aynı şeyini şimdi ayırdılar çünkü şimdi başlayacağım. Ki ani başlayın de şeyi de şeyler kontrol de şimdi gayet anlaşılır. Yani aslında kızılıyor. Nика и ну круто şeyler anlaşılır. Kuşina before Yodas called uranium was ungiven. We have years of research and data alone. Cool church rock, I don't be camera on it. Oh, he's not so studied the year. All about Navajo. I don't know, arson. Togi, Zengi, the Eastern Agency, to Western Agency, all these windmill, took the net is they don't discard they don't in the chapter, it is the Hashi does read the done under the car. But they have all that information. They could tell other than the heavy metal, and they can be basically about that. I don't know that. Oh, sorry, basically, yeah, that the basic, yeah, the heavy metal. About that, I don't know. I use which one. Edo, Benik, not suddenly be alone. As long as you don't disturb it. Link to it, no some your body needs that. It goes into the issue. It's easily it's a immune system. Because Navajo is going down. I think I'm on your agenda there to be reported to the Navajo Nation Health Institutional Review Board, Navajo Nation Human Research Review Board. When people give their presentation, Navajo across the nation, their immune system is really low. Just So study they've been going out to the reservation, chapter presentations, working with the IHS, and working with the test committee, made several presentations in the past, made several presentations to the Navajo Nation, the IRB, and we made presentations at different meetings. Oh, I use this. Lots of knowledge, lots of data that can be shared, can be learned from. They're willing to share this information. A lot of it's simplified. They keep it all teeth. So they keep it all teeth. Consolidation. Yeah, in
Shady person is check. Although a chini show nanas, she and solid she although they yeah no but although a yard the way your canyon are there uranium mine. There's a Provera and not a nuclear, which that also the big kind of or a Korea and Navajo, through my grandparents, since they up, that's not that, they, although, as a memory, members, 110, I keep on this. Although 46 family, I'm a talk kid on it. A day, such as I had nothing, it's so deep. Not sure what all these are, no, none such maybe Gallup quota, that it's not even initial okay, Gusto checked over he professional, about the was yeah, so good now, therapy. And Shay, I eat it good and she Redwater Town Road, on it. Okay, it's a line, they are on Washington, no, I'm not seeing yet. Okay, in Dashing Trouble Business, Joey, the air has been contaminated, the water has been, and of course, you know about the 1979 spill, which affected a lot of people. So our mission, we've been doing this for some time now, and we want this cleaned up, that there's no other danger. And it helps, when people listen to these impacted communities across the Navajo Nation. I feel that, I advocate for my community, and also at the same time, advocate for the Navajo Nation, where these impacted communities are. Oh, that is our work, so thank you very much.
Hi, I'm Johnny Lewis, and I'm the director of the Medical Center and Code Centers we'll be talking about. I want to welcome you all to the university. This is my first foray into the program, so in about 14 months, and I think that's the case for many people. I think it's really a fitting way to break the lockdown to try and connect with friends as a long time partners. So thank you very much for coming. I understand that our president actually changed the rules of masking last night. So anyone who is vaccinated, apparently it is now okay to not wear masks. We did say that for this meeting, everyone would, so I guess it's a comfortable. So, thank you all for coming out. And I hope this is really productive day. I apologize for the back. Good to see you. And our friends that are, I see that we have many other partners, friends from Luna and some of the other staff that are on the Zoom link. So thank you all for joining.
So we will start. Again, folks in the room and on the call, but I dare say at the behest of Dr. Johnny Lewis, we are here. I say that with a smile. But we certainly realize, acknowledge the damage that's been done to Mother Earth affects folks no matter where they're at. We're dealing with the RICA amendments. Get Congress to make it where some of the benefits would go to the down members. So we realize that it's not in a particular area, but it covers a vast area. So again, we thank the university for reaching out to the community. That's really being connected to the people you serve. Thank you for that. So at this point in time, we'll go to part that the agenda that UNM staff had prepared the morning session. We'll go with that medals. I don't know how to pronounce the first name at age. Injali.
Hi, yeah, I'm Anjali Mulchandani. I am an assistant professor at UNM in the Department of Civil and Environmental Engineering.
You have the floor.
Oh, I have the floor. All right. I will share my screen. Would you like me to go into my presentation?
Actually,
or I think, Johnny, do you want to do an introduction?
no, I think actually it would be good if I could do the overview first. And
yes. All right, go for it, Johnny.
Go ahead. Go ahead.
So you'll have to bear with me. I just got new hearing aids, so I can't always hear. I'm still adjusting them. If I don't respond, it's not that I'm ignoring you. I probably didn't hear you. So, so I want to just do a little bit of a quick overview of what we've learned from the centers since the last time you were all here. And then I want to make sure that we can get to Ronaldo Sosi by around 10 o'clock because she has very limited time today. And I think you'll be very interested in what she has to say. So we're going to do hopefully very brief presentations just to give you some highlights and count on questions from all of you to fill in details. So first I want to just summarize the Metals Center, and that's the Superfund Center that we originally talked about doing this meeting on. And that's funded by NIH, and it's a partnership that also includes Laguna Pueblo, Cameron Chapter, Tachi Blue Gap, and Redwater Pond Road, and the other organizations that you see here, SHRIC, and then the Indigenous Education Institute, plus partners at Stanford University. And this graphic really summarizes the whole focus of the Metals Center. And if we think about the mine waste, so we start with looking at what's in the mine waste, what kind of mixtures are there, because that's what's really going to determine what the health effects are. And what we learned through the first part of the Metals Center is that, you know, these wastes have been sitting there for decades now. And over those decades, two things have happened. One, the waste has redistributed. So it's now in many places that we didn't originally think it might be. And we've done some modeling to predict where those places might be. The other thing that we found out is that over all these years, the material has broken down into very, very fine particles. So you'll hear us talk about nanoparticles. And that's what we mean by that. And what that means in terms of health and in terms of the environment, these very fine particles can be lifted in the air much more easily. They can move longer distances. They can move through water. And when they get inhaled, they can have a very different toxicity than we see in other, with larger particles that might either not even make it into the lung or might stay localized in the lung. So that's one of the things that a lot of our biological projects are trying to resolve now is what does that size and what does the composition of each of those particles mean for the toxicity. So we have two foci for the Metals Center, and one is to understand the toxicity. And long-term, the reason we want to understand that toxicity is so that we can design interventions. And you'll hear more about the first intervention that we've gotten into the field in the last year. Deb McKenzie is going to tell you more about that. The other thing, though, is what can we do from what we learn from the composition and how this is moving in the environment? What can we do to stop that pathway? What can we do to design remediation systems? And Anjali will be talking to you about one that we're quite excited about as we go on, and that's the bioreactors that you'll see a little bit later in the agenda. So in the first phase, we had, we actually have added Cameron chapters since the last time that you were here, and Mae Franklin will talk about what we're doing there. Both Laguna Pueblo and Cameron were very concerned about the safety of agricultural produce and whether it was safe, especially in Cameron, to start farming on some of this land and if there was any risk from that. And we've been working with them on that, and she will talk to you about that. But before we hear from Mae, we'll hear from Ilian, who's going to talk about what we've learned about how these materials get taken up into plants. And so that's kind of that first step in that pathway to exposure. So Ilian will talk about that. And then later, closer to the end of the day after the P50, what you're going to hear from Yan Lin is what we've learned on how that material in the plants then can move into livestock. And the P50 that Deb McKenzie will talk about, the Center for Environmental Health Equity, one of the big focuses on that is looking at
that livestock pathway, and now also adding wildlife, because that's something that we heard a lot from community members that they were concerned about. So we've also looked at impacts in different systems in the body. We've looked at the gut and we've looked at the lung. And one of the really interesting things that came out of the first series of studies in metals, people have known for a long time that uranium doesn't get absorbed really well if you ingest it. And this goes along with that concern about agricultural produce. So only a very small portion of it gets absorbed from the gut. But what one of our researchers, Scott Burchell, has been working on is what happens to what doesn't get absorbed. That moves down into the intestine and it exposes the cells that are lining the intestine to a much higher dose. And, you know, if you don't know a lot about what those cells do, you think, well, that's great, it's on its way out anyway. But it turns out that there's actually cells in that intestinal lining that control the immune system. And one of the big things that we have found from the beginning is effects of these mixtures of metals on immunity. And we see that, and we heard this from clinicians in IHS when we first started this research, that there's an inability to mount an effective immune response. So they have to treat with much higher levels of antibiotics because there's some compromise in the immune system. And that's something we've been looking at a lot in the first phase of metals. And Deb will talk a little bit more about that when she comes up. So that will be a big focus as we go forward, hopefully, into the next renewal cycle. Some of those studies will be happening in this year. And then Anjali will also talk about some of the interactions between some of the, and Elian also, some of the work they've done looking at the chemistry of those particles as they go into plants and how that interacts with the microbial community. And there's a connection there because if you're looking at how those microbes, those bacteria that live in the soil and they are in the water systems, how they can transform this material and change how it goes into plants, we think something kind of parallel might be happening in terms of when these cells in the intestinal lining get impacted, because we have lots of microbes that populate and help regulate the function there too. So we have some parallels between the environmental studies and the health studies. So if we look at the studies that we're doing then, I mentioned the agricultural concerns, and we're now focusing a lot more on how this material is moving through the environment. That's a big part of the second cycle of metals, we hope. And it really is directly responsive both to the questions that we're going to Pueblo and the questions in Cameron chapter. Blue Gap Tachi also has similar questions on that, but focusing more on the livestock side. And then in both Redwater Pond Road and in Blue Gap Tachi, we are also looking at this clinical trial that Deb is going to talk about. So looking at whether we can use very simple interventions that in the laboratory have been really effective in stopping some of the damage and in some cases even reversing it. That clinical trial, unfortunately, well, fortunately and unfortunately, started just before COVID. So we have limited data now because we had to stay out of the field, but Deb will update you on that. So what you'll be hearing then is about the clinical trial where we look at damage to DNA and whether treatment with zinc can repair that damage and restore the function of the immune system. And Deb has some exciting preliminary results to share. And then Sarah and David will be talking about the community participation in that design of that study. So we didn't just think something up in our offices and walk out and say, okay, this is what we're going to do. There was a lot of planning that went into it. And their input has been really critical, and they'll talk more about that. Anjali, right after Ronaldo speaks, will talk about what we found out about these fungal communities that help to increase the biomass. And you can see in this picture without and with the fungal component, what these materials do to change the growth in those plants and how that might be affecting both the uptake and providing an option for remediation. So I mentioned the Center for Native Environmental Health Equity. Deb McKenzie is going to review that for you later. One of the things that's very exciting for us about that is we're looking at, in addition to these metals that are in the mineways that we know are pretty widespread, what happens when you look at some of the emerging contaminants? And you hear a lot these days about microplastics. And as we look at how, Native Beach Equity is actually working with some of the Northern Plains tribes as well, with Crow and Cheyenne River. And one of the big concerns up there that they brought to us was what happens when we have these open burning dumps that are burning at low temperatures and you see these clouds of smoke coming out. And we know that that low temperature burning is also very similar to what a lot of people here do in terms of barrel burning. And when you don't burn plastics at really super high temperatures, they do tend to put off a lot more of the component contaminants. And then Jorge Gonzalez, who used to be part of this center, is now at Oklahoma. And one of the things he's been looking at is what happens when those little microparticles of plastics get into water supplies. And so looking at if we have that joint exposure from plastics that break down in the environment and metals, what does that do long term? And so they'll be looking at health studies and looking at some field collection of data to try and answer those questions. And then we also have our ECHO cohort still going on, the Navajo birth cohort study. And one of the things we've really been focusing on in this last year is looking at what's the impact of COVID been on the kids, on the parents, and what is that going to be long term? And I'll give an update on that. You know, we are now following, with the help of the ECHO funding, we're now able to follow the kids in the birth cohort study up to 8 years of age. We're still seeing what we originally saw, the delay in language development, much more obvious in the boys than in the girls. But as we look, you know, what these impacts of being closed in for a year and not going to school and not having a lot of the contact with family, what kind of impacts is that having long term? And I'll show you what we have so far. We have just our first analysis of some of those data. So we'll talk to you about that later in the morning as well. And another thing that remains really central and really important to everything that we do is trying to make sure that we have community involvement all through the process. We had a really exciting opportunity about, let's see, it was the October before COVID, where we got to have a lot of community members come to an international science meeting with us. And that was hosted in New Mexico. And so it was a perfect opportunity to bring a lot of people together. And, you know, we talk a lot about making sure that we're culturally sensitive. And I think one of the really interesting things for us during that process was hearing back from community members about, boy, you have a culture too that you're dealing with. And dealing with the molecular scientists all the time is really tough when we're talking about these big gaps. And so trying to increase our understanding in both directions. And I think the process of that was really interesting. It was really fun for all of us. I think all of the scientists who were there also really enjoyed the opportunity to see where these things they do in Petri dishes in their lab end up impacting people. So I think everybody learned a lot from that. And these are huge teams for all three of these studies. I just want to take that minute to acknowledge everybody's participation in the work. And I want to make sure that we can get to Ronalda. Ronalda, are you on? Ronalda has just taken a job with the, working with the trustee, with Dareth Watchman Moore. And so she's going to be having a meeting with them at 11 o'clock, and the rest of her day is pretty taken up. But she's done some really nice work developing water treatment systems. And I really wanted you to have an opportunity to hear from her. Or we have everything here. I think Ronaldo's slides are in that same folder.
I could share my slides if you don't have it ready.
Okay, perfect.
Okay. Okay, let's see. Why it won't allow me to share.
We see you.
Were you able to find the slides? Because I can't share it on my end. It's only allowing for like whiteboard.
What was the title?
Say that again.
What was the title, Ronaldo?
HEHSC's 518 RSOC.
Huh. Oh, there. Down further, Michelle? Yeah. We have 2 copies. Oh, one's PowerPoint. Okay, yeah, that looks like it.
Sorry about that. I can go ahead and introduce myself. Yat Eshe Ronaldo Sosian Chien and Ishit Nashasha Bashashin Lashe Dashache Do and she Dashanale Totla Kande Shiyaho Ado Ade Shmasan Bushma Shik Kedahat Adainle Missoula Montana de Kesh Edo Ade Shinan Nishash Le August be Le Bozeman, Montana, the Montana State University, the Asia Nanish. A Ajigo A Sahat Al Shananish Idolil. I'd like to say thank you for allowing me to present what I've been working on and what I will be working on in terms of my postdoctoral research at Montana State University, although it was started at the University of Montana. Are you able to get that slide up? There we go. So I started back in 2013 on this idea of addressing water contamination issues within my own community of Sweetwater, specifically targeting Teta area, and which is surrounded by communities of Red Mesa, Emmanuel Mission, Sweetwater, as well as Tisnaspas. So throughout my graduate work, both my master's and my doctoral work, I was working on looking at the water contamination issues, the extent of the contamination, and how that I can address these issues. And part of what I was trying to do was really trying to figure out a way to address all of these areas. So in a lot of these sites, so this is one of the wells that's notorious for uranium contamination. It oftentimes has a warning label such as this one here at the well, but the problem is that the well, this location is about 50 to 100 yards away from the actual tap. So people don't really go and explore, and just with my interactions with community members, it's been really something that I've been seeing, and I've also been seeing not only working with communities addressing like their concerns for their livestock, but as well as for not necessarily drinking water, but household water needs. And because there's about, in the community of Sweetwater, there's still about, I think, between 15 and 20% of homes that don't have access to running water. It's just because it's hard. So we've been developing at the lab at the University of Montana these materials called silica polyamine composites. They're metal selective materials, and they become in a variety of forms like this, in different colors, different styles. They're all selective for different types of metals, but the ones that I was looking for are the ones that are selective for cations, for uranium, for arsenic, for vanadium. What is happening is that, in theory, is that as the water is being fed through from the well, as you could see here, it'll bind to the certain sites of the on those composites and remove contaminating elements such as uranium, vanadium, and arsenic. So that was just something that I was working on. And my next stage is to start optimizing this filter so that it's not so bulky. It's more of a handheld filter that would be available, which we could, with the Crow, we're working on making it a filter that could attach to their private wells. But out on Navajo country, we want to have it so that it's a handheld portable filter that you could take along with you to when you're hauling water. That way it's filtering the water as you're hauling water. So that's just something that that we're working on, and hopefully within the next 2 years, we'll have an actual working handheld commercialized type of filter. Next slide. And then with that, I just wanted to say thank you for everybody, especially the overwhelming gratitude to not only my family, but the communities of Twi'leka, Red Mesa, Emmanuel Mission, and Tisnos Pas.
Does anyone have questions?
Does anybody have any questions? I don't know if we're allowed to take questions. Okay. Well, thank you.
Fernanda, whoops. Do you have any thoughts on how long it'll be in terms of getting this into a field production state?
So I'm estimating that part of my postdoc experience at MSU will be making that filter to making it to a point where it could be implemented, but so probably a year to a year and a half before it'll be ready. Because right now we're experiencing issues with flow. So the water is not filtering through quick enough, and I think it's just the design. So we're trying to optimize that filter. I'm hoping that within a year to a year and a half, we should have a working prototype that we could implement in the field and see if that's going to be effective. So hopefully by the end of 2 years, we should have something that would be available.
And that'll be on a sort of a remote well scale or on the household scale?
So we're going to be aiming for both. So the household scale would be for individuals like on Crow Reservation, they have private wells where you could just set it up like sort of the way a water softener is set up. indoors. I have a private well in my house in Montana, and I think that would be, I'm thinking about a scale that's about, I would say like 11 inches and probably about 10 to 9 inches in diameter. The other handheld one that's for like the unregulated water sources, that one's gonna have to do be slightly, probably slightly bigger. I don't know. We're still trying to figure out what would be a really good solution and a nice handheld way to use these filters and implement these filters.
And what is your anticipated flow through those? What do you have now and what are you aiming for?
Can you repeat that question? Because I can't.
Just some idea of the flow that you have now and what you're aiming for ultimately in terms of the capacity.
So in terms of capacity, we are looking at anywhere from 98 milligrams per milliliter, which is about, so if we were to run it in the lab through a setup where it's using a motorized system, then it would require, it would, in let's say a 2-liter solution would run through a small 2 milliliter column or 5 milliliter column. It's like maybe, I don't know, a few inches in length. It's like 5 inches in length and like an inch in diameter, and it'll filter the 2 liters. It'll remove about 98% of the uranium. Arsenic is a little bit more challenging because you have arsenic 3 and arsenic 5, and it was important to figure out the species of arsenic before, because you would have to adjust for the species and use different composites. So those would be, I think we were looking at anywhere from removal of like 60% to all the way up to 88%. For the vanadium, it was just, it was really effective. It was also about more than 95% effective. In terms of flow, we're looking for flows that are similar to whatever that is flowing outside of the wells, the unregulated water sources, because those vary by well. Some of them have very slow flow and some are very powerful. So I think it also depends the time of the year as well, because I noticed that as you went further and further into the summer season and later into like sort of like fall, you would have much slower flow by the end of the summer, and it just has most likely to do with water levels and water availability.
But you're shooting for something that would not take longer for the filtration than someone would spend at the well now.
Yes. So something that we're trying to keep the flow the same or around the same of whatever is happening at the unregulated water source.
And this is all being done with just gravity flow through and pressure?
Yeah,
No,
we're gonna.
energy application?
We haven't. I haven't worked on it extensively within the last year, but starting in August, I'm going to be moving to Montana State University, where they have an engineering school that specializes in like 3D printing, and we're going to do troubleshoot a lot of the issues of flow to ensure that we're not having like a drip versus like an actual flow. I think Nicole Thompson might have a question.
Hi, Ronalda. Can you hear me all right?
Yes, I can.
Thank you so much for your presentation. I was just curious if you could comment on any anticipated difficulties or solutions for cost and distribution of a filter once something is developed that you think people would be willing to use?
So I think first and foremost, it's always important to ensure that whatever is ready for commercialization goes through all the necessary approvals, because they're going to be, if it's going to be used for drinking water, or in those types of cases, we want to make sure that all that safety is being addressed first and foremost. Secondly, other challenges that I could see is I don't know if this is a current issue now, but if these filters do get implemented and are out in the community, the one challenge that I would see, a biggest challenge is changing out those particles. So the particles are designed in a way that they're reusable. So you would have to take it to a place or a lab and have them strip and remove the uranium, the arsenic, and the vanadium, whatever it catches onto the surface of those composites, and then activate those sites and then put them back in and then send them back. So that would be probably one of the biggest challenges that I would anticipate, is that process to happen. Right now, we don't really, I haven't done any heavy studies on how long it'll last. So that's also going to be part of the postdoc experience, is to really see this specific filter that's going to be ready for commercialization, is how long it will go through, how many gallons it can take before it says, okay, I'm fully saturated, I need to be stripped and regenerated. So those are some of the challenges. The other challenges that I would see is if it's going to pose, for an example, for uranium, if it's because as the water is flowing through and it's picking the different particles of elements of like uranium and concentrating it on the surface of that composite and holding it there, I don't know if it would create a problem taking it out off the reservation to a lab that would remove all of that. So there's a lot of logistical challenges in terms of policies that I think that we would need to address before it could fully be implemented. I know there's a lot of those are some of the issues that I think are important for me, and I would like to have that worked out prior to really doing an implementation study and to truly understand what other challenges there are.
Thank you so much.
Any other questions? Okay, thank you.
Thanks for raising all of those issues. I think Ronaldo's discussion there, the challenges that she's facing are really key in any considerations. Figuring out ways to get the uranium out has been a challenge for a lot of people, but really it's what are these barriers to implementation in terms of flow, in terms of waste that gets generated, in terms of any extra energy. And so thank you very much, Ronaldo, for discussing that with us. So you want to leave next?
Is she still on the call?
Yes, I'm still here. I just muted my
Thank you.
myself.
Yes, it is Dr. Sosi. Yeah. What you're studying is very intriguing, and between the three of us, Honorable Edson Manika, Honorable Paul Begay, and myself, we certainly appreciate what you're doing. You know, it just seems like aquifers that are underneath all Navajo land seems to have this specific if the main thing is the bedrock, which, you know, the aquifer sits, it just seems like that's also the sandstone. Sandstone that contains the uranium. Somehow that water dilutes the uranium where it's appears in the water. Certainly, we are very interested in how then your work can be used to get bigger. What would you say? Bigger systems to help address the water systems that are operated by NTUA. And certainly your work can lead to that, and we appreciate that. And the thought is, how do we make it your little project, your little 5 millimeter instrument, how do we make it to where it could do industrial filtration? And certainly, and that would be something that we would want to take to our congressional delegation to see how we could get more folks to fund something in that manner. So your work is very important. We appreciate what you're doing. Okay. Went to school.
I think that's definitely a possibility. So to have like an area alongside the NTA facilities that are pumping the water to households. So I know that in the Sweetwater, Red Mesa area, up in that area, they're actually doing blendings. Then that started in 2015. But prior to that, we were all drinking groundwater. That's kind of amazing to me. If you think about it, you know, that it took until 2015 for that to even happen. So, but they're purchasing water from a municipal water source in Farmington, New Mexico, and pumping it down to Red Mesa and Mexican water, and then using a blending method to then blend the groundwater with, so that the levels of like arsenic and other elements of concern, to reduce those limit those levels. But there are sometimes, I know, like for an example, I used to sample my grandmother's household tap water as a control, because I wanted to see what was really happening. And at one time in my grandmother's tap, it just so happened that when I collected it, had 16 parts per billion arsenic, which is 6 more than the allowable limit. So, and that's even happening with blending. So there's definitely a fluctuation. Yes, this problem is a long-term problem. I don't know if, even if we do all the remediation that we could and clean up all of the abandoned mines, and which is part of what the trustee work is is going on, is going to be happening in both, at least the one that I'm working with in Touchy Blue Gap as well as in the Tata area. Even if we do all of the cleanup, we're still going to have to, this is like a long-term legacy that we're going to be dealing with. So I felt like it's important to have something that could possibly be used only when we're accessing these unregulated water sources. But I think as of right now, NTUA is doing an excellent job in ensuring that water is safe and the ones that are going out to the households that have running water systems.
Anybody have any questions, additional comment?
Okay. Yeah.
Thank you, Bo and John. We appreciate your work. Folks in the room, just know that this three delegates were the first of the 24 to get a first chance. My colleagues here got the second one early on. After the 3-week period, and they waited 100 days for it. So overall, I guess, meet the criteria to not wear a mask. Was anybody else want to pose a question to Dr. Sosky? We appreciate your presentation. Now you have to go back to work.
I could have definitely made it longer and talk a long time, but I knew I wanted to respect everybody's time because there's a lot of stuff that I wanted to share, but I knew that the most important part was to highlight the point of use filter. So, but if you have some time in the future, you know, I'd be happy to answer any questions. I can share my email. So it's just sosirl@gmail.com. If you have any questions, feel free to reach out to me and I'll be more than happy to answer them.
Where are you working now?
I am currently, so I have a dual appointment at Salish Kootenai College. I'm the science research coordinator for their STEM Academy program, but I also work at the University of Montana. I teach a Native American Studies course, Ecological Perspectives of Native Americans. And then I also run like a STEM sort of program within the University of Montana. But I was recently awarded a grant by the from the NSF and so, or from NSF, and I'll be starting moving in August to Montana State University to start the continuing on the commercialization of the point of use filter.
Fantastic. Thank you.
Excuse me?
Keep up the good work. Fine example of this Navajo research. We appreciate it. With Ayla? Thank you. Let the record show we have a fourth member of the Health, Education, and Human Services Committee member enter the work session room. Honorable Cornell Bologna. Introduce yourself.
Thank you. Good morning, everybody. I'm Delegate Cornell Bologna. I come from Tohatchi. Turkey English, Ashi Bashishin, Administration Dashi Twan, Mention. Thank you for having us today, and sorry for my tardiness. And I guess I'm here to come whenever I can. Thank you.
All righty, are we ready for the next one? Perfect. Well, thank you all for having me. My name is Anjali Mulchandani. I am a new assistant professor here at UNM in the Department of Civil Engineering. I'm an environmental engineer by training. And today I'll be talking about fungal bioreactors to remove uranium. This will essentially be a two-part presentation. I'll be directly followed by Eliane El-Hayek, who's in the room with you today, and she'll be talking about uranium uptake by plants. But I would like to acknowledge my co-PIs on this study, specifically Dr. Jose Serrato, as well as Jennifer Rogers, Eliane El-Hayek, who will be speaking to you later today, Guan Lazama, and Scott Fendorf. If I could have the next slide, please. All right, so just a brief summary of what we've learned during phase 1 of our work. We've learned that the chemistry of abandoned uranium mine sites or locations that are impacted by toxic metals like uranium actually impacts the remediation efforts as a whole. So the toxic metals that we've looked at include uranium as well as co-occurring metals like arsenic and vanadium. And as it turns out, the presence or absence of naturally occurring minerals such as calcium and iron and their concentrations, as well as the water chemistry of that region, be it the pH, the dissolved oxygen, all interplay with one another. And that impacts the form of the metal, whether that be as a complex or a precipitate or a solid, or it goes into a soluble state, as well as an impact on the uptake of metals by plants. So the water chemistry in the presence of minerals will determine the level of uptake of uranium, arsenic, or vanadium by plants, should we be trying to use them for a beneficial purpose like remediation or for agricultural purposes as well. So next slide. And that all leads us to kind of designing our next level bioremediation study. And our goal here is to advance bioremediation risk reduction strategies for metal mixtures by starting to understand whether we can beneficially use plants that are interacting with fungi to remediate our metal mixtures. So you may ask, why are we thinking of using fungi? Well, over the course of our studies, we've learned that fungi actually have better uptake of metals than bacteria. They are resistant to toxins and stressors. They are usually found mutually with plant roots. And it turns out that fluids that are secreted by plant roots will actually interact with fungi to help complex metals. And when fungi and plants interact with one another, we have seen a 15 to 30 time increase in the biomass, the actual plant as a whole. We've also seen a 2 to 3 time increase in the length of the roots of these plants as well. So our goal here is to design bioreactors to understand this interaction of plants and fungi in real-world metal mixtures. So as you can see here on the right-hand side, a bioreactor is essentially just a fancy temperature-controlled chamber. And our goal here is to have pots that will have soil from different regions from contaminated sites. We will also have native grasses that are inoculated with fungal partners, as well as minerals, whether these be naturally occurring minerals like limestone or synthetic or engineered nanomaterials. And we will track and monitor the plant growth and the uptake of our metals like uranium, arsenic, and vanadium over time. The effluent, or the water that is collected from the bottom of these pots, will then go into our BP gut team or bioproject gut team to then conduct a toxicity test to see if there's any long-term health impacts of using this bioreactor. And overall, what we would like to do is imitate or understand that there is a wetland that is located directly south of the Jack Pile mine. And in that wetland, what we had seen was that there was a 7 to 10 times lower concentration of uranium than in the adjacent mine site. So we'd like to see if this result is imitated across all different soil and water types or only specific soil and water types. And once we have an understanding of how soil, water, mineral, and metal chemistry interact with one another, we can then start to do predictive models or maps and create a geospatial temporal map to understand the level of bioremediation or the extent of bioremediation that could occur across different abandoned mine sites at the Navajo or Laguna Pueblo locations. And with that, I would like to wrap up my talk and open the floor for any questions. And I'd also like to call on Eliane Alhayek to assist me in answering any questions that may arise in the room.
I have a question. My name is May Franklin. I'm from Cameron. I'm really intrigued by what you just said. We are planting along the riverbed, but that's not where the uranium sites are. The uranium's outcrop along the river has been sort of outside the river corridor. So if these uranium sites have been disturbed, the assessments have shown that uranium from these sites are going down into the river. So not really into the riverbed itself. I mean, we're talking about washes that go into the river. So I'm thinking, if what you're saying, then the ground should sort of dissipate a lot of that uranium before it hits the river. Is that, I don't know, that's my thinking. Am I right?
It is possible, yes. If you have specific native grasses or plants that are planted in locations that are then going to uptake that uranium prior to that uranium then going into the river itself, then you can limit the movement of those metals.
Ah, okay. Thank you very much.
Of course.
If you can give me 1 minute. Anjali, could you also, we talked a little bit last night, I know, about just sort of scale that this might be able to be implemented on in a field setting. Could you just maybe talk about that for a minute before Leon starts?
Yeah, so the scale at a field setting would essentially be any locations that already have native grasses. You could also implement fungal mixtures there to start to do uptake as well as additional plants that are inoculated with fungi. And this can essentially go across any location that is impacted by uranium or any metal mixture. So we're thinking a larger field level scale as opposed to a smaller, just a small single site. And of course, then in that scale question, as our bioreactors will start to give us understandings of which specific plants or which specific fungi are best for specific water or soil conditions, the type of plant or fungi that you implement at a site is then going to vary. And so we can have different mixtures or combinations of this, of the type of plant or fungi that we're implementing. So it's not a one size fits all solution. It's a per specific site, you choose a specific application.
So this is really something that could be tailored to a site-specific mixture.
Yes, yeah, it's tailored site-specific mixturing. And so once we get our bioreactors, we would then first start with mapping. Well, we take field samples and understand what is the chemistry at each location and which plant should we implement at each location. And then we would have a tailored remediation strategy at each site.
And could you envision, so I know a lot of the initial discussion on this has come from the Laguna flowing water wetlands and that kind of setting. Could you envision something that might be a portable unit that could have flow through from a well? Is that a reasonable kind of future goal?
That I'm less certain of. The things that we are thinking of are more in-ground applications. However, if you could have some sort of a, if I'm thinking of putting my gardening hat on, a raised bed type reactor of sorts that you could move around, then possibly you could do that and connect it to a well. But then that gets into the more creative reactor design type strategy. Yeah.
Could you see these, the fungal organisms living on filter membranes or something in that vein in the future?
As long as there is a symbiosis between the fungi and the filter that they're living on, then I don't see why not.
So hi everyone, I will follow up here with the Anjali presentation, and I will bring up here the questions: can plants pick up uranium, and when that can happen? I started in my research work to investigate whether the contamination of uranium in surface waters does reach the plants or does not. So our research group has been studying the mobility and the accumulation of uranium along Rio Pawati, which is just near the Jackpal mine site in New Mexico. And there, the concentration of uranium in water has been detected higher than the maximum contamination level defined by EPA. Various plants of importance to the community were collected along Rio Pawati to look for the uptake of uranium in the plants, such as salt cedar, grass, and willow. We did measure uranium weather mainly in the roots of the plants and with the highest concentration in the root of salt cedar. So here, we wanted to more understand, okay, what are the environmental conditions at the site that can help or affect the uptake of uranium by the plants? So we did hydroponic experiment in the lab by exposing the plants to uranium in water under environmental conditions relevant to the mine site, such as the concentration of uranium in water, the level that we detected in the Yopawati, and the range of calcium concentration and the pH. Why calcium? We were mainly interested in this element as an abundant natural element in water known to highly affect the chemistry of uranium in the environment. What did we find in this hydroponic experiment? We exposed the plants to uranium over 2 weeks. But the interesting thing here that the uranium removal by the plants happened very fast, like within the first 24 hours of exposure. And that removal only happened in water that did not contain calcium or when calcium was low in the water. If you look here at this electron microscopy image, you see this bright spots. This is uranium on the root surface of the plant, showing how uranium was immobilized on the surface of the roots during the experiment. And that's how we got like a removal that can, the first 24 hours, that was around 40%. And if you look there at this dark image here, it's showing that uranium was not there present on the surface of the root. And that was when calcium very high in water. The question that was then raised, okay, what happened then if we have higher uranium concentration in water? Because some sites may have a higher concentration. We repeated the same experiment, but with exposing the plants to higher concentration of uranium. And here it was a very interesting observation. When calcium was still low in water, same thing, uranium was immobilized, was mainly present in the roots of the plant with a very, very low uptake to the aerial part of the plant. Once calcium started to increase in water, here I'm showing you like a graphical that like illustrate how the roots, how the cells in the roots of the plant, they are distributed. And you can see here with this red arrow that the more like we were having calcium in water, uranium was more penetrating deeply into the structures of the root. And that's how uranium was able to get to the stem and then go up to the leaves. So these findings here help us understand the different pathways of uranium in the plant with respect to the calcium concentration in water. And with these findings, which here are really highlighting natural processes that can happen in the environment and may help or prevent the uptake of uranium by the plants. And we hope that we will be using this knowledge to develop the future bioremediation studies. So yeah, this is what I mainly wanted to share with you today. Yes.
I have a question on that plant. When you, after the uptake, the plant takes the uranium and all the contaminants that come with it, that plant can't be used by human consumption or cattle? Will it be contaminated with the residues left in the plant?
Yes, so this project has both sides. If the uranium was taken up with the native plants, growing there on the sites, yes, this may be of risk that can be ingested with the livestock, and we will be discussing that in the next project that we will be presenting here. And it has also another side where we can have plants, other plants that we grow on the site, so they can help to clean the water and get uranium removed from it and immobilized inside the plants.
One more question on this. When you do the testing on the uranium, the high rates, the low rates, does that uranium or when it starts contaminating the plant, how high does it have to be before, or humans, when we get contaminated radiation, we start to
yeah, you're talking about the concentration of uranium in the water?
Yeah.
So here we tested like both ranges of uranium, the one that we were measuring in the water there, and we also tried higher concentration. And with both ranges, we did observe that plants can immobilize this uranium depending on the initial concentration of uranium. So if we, like in here, when uranium was like in this range, which is like kind of the range of uranium we are measuring in water, we saw that when calcium is low, we may see immobilization of uranium on the roots of the plants.
So in your research, you're saying that the uptake of the uranium into, let's say, the outside layers to the inside layers depends on the concentration of calcium.
Mm-hmm.
And,
Yes.
and so in your study, then, were the uranium more prevalent in areas that had high alkali soil?
Yes. Yeah, actually, this is very relevant to that site here because we have hard water that have like high calcium concentration. So it's really relevant to what we have on that side. And this is actually what can like help us like think how we can develop any bioremediation project that can be like as a continuation for this project.
Then we have the Russian olives that almost exist or are prevalent in the same areas that the salt cedars grow. Have you looked at the Russian olives?
No.
No, just you concentrated on the salt cedar.
Yeah.
Okay. And not on the junipers that are up on the high sandy slopes and up in the higher elevation.
No,
Not
I
that-
don't believe so.
Not that. Okay. So what you're saying is we ought to let the salt cedar grow instead of trying to eradicate them.
Yeah, I mean, they are. I know that salt cedar, there is like the certain traditions ceremony. So here, the good thing that uranium, at least we know that it's not taken up to the aerial part as much as it is like in the roots of the plants when we have the uranium in the soil or water.
I know down toward Bernardo, that road that goes to San Antonio, from San Antonio up toward Carrizosa, there's high numbers of that salt cedar that burn. Do you think that that burning released some of the uranium into the air?
I believe that this is a very interesting question, and it needs to be. Yes. Yeah, this is a very, very interesting question. Yeah.
Russian olive, we need to do the Russian olive too, because where I come from, there's a lot of Russian olives.
Yeah, that Russian olives is something that we really need to take a look at. So it's very invasive species.
Mm-hmm.
And it was brought in to the area with the advent of the Bureau of Indian Affairs schools. They used it as hedges. And then we just took over the landscape, river bottoms right now. Along the San Juan, along the Rio Puerto. Yeah, wherever there's moisture, there's. Okay,
Yeah.
thank you.
Thank you.
Hi, this is May Franklin. I wanted to make a comment.
Yes, Franklin, I'm hearing you.
Okay. I was just taking a look at my soil test reports that I got back from Brigham Young University that analyzed our soil that we submitted. And by the way, if Navajo Nation is listening, we really need a soil testing laboratory. We keep sending our soils from Coconino County. We have to send it all the way to California. And then I know that one of our EPA companies that's doing assessments in our community, they sell they take and send their soils to, I believe, like Kentucky or something like that. So we really need to have Navajo Nation have their own soil testing laboratory. So, so we can have a better and quicker turnaround and be able to move a little faster on these information that we need. One of the question I have regarding my soil report is that it doesn't list calcium. I guess you just request that and they'll do it, I'm assuming. But it's very interesting that calcium helps to I don't know what the word is. I'm just learning all these new words. Adhering uranium to the roots, whatever that word is. But it's very interesting information. Thank you very much.
Yes, thank you. So yeah, measuring the calcium concentration in the soil solution and the pH, of course, because the pH has also a lot of impact on the chemistry of uranium and the presence of calcium. So these are very important information to know about the mobility of uranium in the soil and then its bioavailability.
Thank you, Ms. Franklin. This is Delegate Daniel. So, Navajo Agricultural Products Industry has a U.S. certified soils lab, but I don't think they would be testing for the uranium or the arsenic. They basically test for the nitrogen, potassium, and phosphorus. But I know that Navajo Technical University was also moving toward establishing a soils lab to basically test for some of the same items that in the report, uranium and arsenic. And in the word Anjali, is it?
Eliane.
Elaine, where did you send your samples? These plant tissue samples?
It's here. We do analyze them at UNM laboratory.
Here at the university. Okay. All right. We'll just have to see. Look at what kind of equipment they use to see how we could maybe perhaps diversify NAPIs. Soils lab.
Yeah, I'm sure there's different equipment for that.
Yeah.
I would think they have that. Yeah. They're just geared more towards agriculture.
Yeah.
Okay.
I have another question.
Thank you. That's good information.
I had a question about when you're doing the samples, the plants. What kind of plant was that? Did you use? Because there was talk about how cannabis will pull contamination out of the soil as well.
Yeah. So for my experiment here, I use master plant. It's a hyperaccumulator of uranium, which can be used like for from the point like of view of like a remediation perspective. So yeah, for this experiment in the lab, this is a master plant.
So master plant is really big.
Yeah.
And cows don't really eat master plants and sheep and stuff. So after the plant gets mature and starts to dry up, and then dies, it sits there, it's dry still.
Yeah.
What happens to the content, the radiation in the plant? Does it still remain?
So to be yes, in the aerial part of the plant.
It stays in the plant. So
Yes.
if you go out there and tear the plant and you're cleaning your yard or cleaning some area, will you get contaminated from that moisture, the uranium?
You mean when they get dry, the
After
area?
they're all dried out and somebody goes in there and tries to clean up all the moisture plant, will they get contaminated from that?
It will depend on the way of handling the plants. Yes.
What happens to the radiation when the plant dies? Does it still contain radiation in the dry state?
So for the radiation effect here on the plant, we don't have a lot of answers for that because like most of our study that we do is with depleted uranium in the lab. And what we observe as toxicity for uranium, it's mainly as a chemical toxicity, not really radiation. So for that, it should be like further study that should be done to answer this question. Yeah.
Thank you.
And I guess I missed the last presentation, but I know that up in San Ildefonso Pueblo and Santa Clara Pueblo, they were using mushrooms to take out the contamination. And then we've also heard that sunflowers.
Yes, yes, sunflower, they are like very typical plant that are also used in experiments in labs to remove the uranium from water.
Okay, and then I guess in this aspect, with the salt cedar, were your samples basically using the roots and not the balance of the tree?
So for the salt cedar that we collected, they were like this big. And what we did, like we took samples from them, from the roots and from the aerial part of the plant, the stem, the leaves. And that's how we detected that most of the uranium is present in the roots and not really getting up to the aerial part.
Okay, that would be on the young plants.
Yeah, yeah. Yeah, we did not like do it with the trees.
And
Yeah.
you didn't core the bigger core samples out of the, let's say, the mature trees?
No.
No? Okay. That'd be interesting.
Yeah, you know, like there on the site, like here we started our investigations with like 3 types of plants, but I believe that like many plants can be collected there to look for like any potential uptake of uranium.
I read the question about the plant. When it's growing and it absorbs all that radiation.
Uranium.
Uranium. Then at what point does it start to break the plant down?
You mean like to die
Yes.
after that? So my plants, like in the lab, when I did my experiment, they stayed like for almost 35 days with very high uranium concentration in water, and they were very healthy. They were very happy. But these are like hyperaccumulator, which means they can tolerate high uranium concentration. But for the other species of plants, so that like need to be examined to see how much the plants can tolerate and for how long uranium concentration.
Questions?
Yeah.
And I guess it reinforces the aspect as what Dr. Rick Gay stated, everything is interconnected.
Yes,
And you can't really say it's isolated.
yes.
And I guess then part of the work, then we have to start looking at the other plants that are in the waterways. Again, thought of Russian olives and maybe some of the areas where there had been mining. Look at the juniper and perhaps the sagebrush
Mhm.
and even the creosote.
Okay.
Yeah.
Yeah.
Those are some thoughts. Thank you.
The issues that you all were just talking about though are so important because it's when we look at any of these filtration or removal systems, the problem that you end up with the uranium concentration is you create a mixed waste. So it has both the non-radioactive metals and the radioactive metals. And then you run into a thing where nobody will take that waste. It's really hard to dispose of. And so figuring out how you can remove the uranium, but then deal with what's left is a real problem. And that's really what you're getting at with what's left in the plants and
then I guess the other thought is, when does the plant convert the uranium to radium? Or does it?
I don't have information on that. Yeah.
And radium is got such a bigger half-life.
well, I mean, yeah, you're probably still looking at the normal decay chain on that. But yeah, that's been one of the issues on a lot of the really simple water purification systems that people have come up with. You know, I remember talking 10 years ago with Navajo, PA, and the conversation was, yeah, we have these really simple systems that are basically clay-based, and we can give them to people and it'll pull the uranium out. But we don't know what to do with the clay that's left behind because now it's contaminated. Yeah, you'd have to send it to WIP, right? Which is a whole other problem. But I mean, it becomes really complicated really fast. I remember when I was working at Los Alamos, there was a field that they had used for testing strontium explosives. And we didn't know, the history was that it had all been cleaned up and we had pictures of these big dump trucks pulling tons of material off of the surface and hauling it away. And we picked up a salt bush and took it back to the lab, and the concentration of strontium in that salt bush blew DOT standards. If they would have stopped the truck transporting it to the lab, they could have been busted for it because the concentration was so high. So especially for these things that interact with calcium, it's such a normal thing for the plants to uptake, and you can get some pretty high concentrations.
Yes.
Thank you.
You're welcome.
It's okay. It's okay. Which one is yours? Do you remember what you called it? GHSC, of course. Yeah. Thinking zinc 2, I guess there. Yeah, that one.
This
one? That's it. Okay, great. Let me go ahead and share the screen. Okay, we're gonna switch gears a little bit right now and talk about our ongoing and hopefully to be expanded clinical trial, which is we've undertaken to try to mitigate some of the toxicity from some of the metals that we're talking about now, the uranium, the arsenic, and vanadium. So we call this Thinking Zinc, and we'll have Sarah and David talk a little bit more about how that name came about. Slide. So the purpose of our study is to determine whether dietary zinc supplementation can mitigate some of the toxicity from chronic exposure to uranium and arsenic. And we know that from laboratory studies, we understand how arsenic and zinc and uranium can interact with cells and proteins in our body. We have zinc binding proteins, so proteins in our body that function in DNA repair processes that require zinc. And when arsenic and uranium are present, they actually can kick out the zinc. So they compete for that zinc binding site. And so if you have high levels of metals and low levels of zinc, then these proteins aren't functional. And so we've discovered that a lot of the studies have shown that increasing the amount of zinc that's present can restore the function of those proteins. So zinc binding proteins can regulate a lot of cell functions, and supplemental zinc can protect against the displacement of that zinc from these functional proteins and restore the activity of those proteins. And it's been shown that zinc supplementation can improve both immune function as well as reduce the amount of DNA damage that's present. And so that was the premise for this study. We know that from biomonitoring from the Navajo birth cohort study that we see elevated levels of urine uranium, so we know contamination is there. We also know that zinc levels are relatively low in this population, and so there could be an imbalance in the ratios of contaminants to beneficial zinc, and this could be offset by supplementing zinc. So our study design has been set up to where it's a single arm cohort study where each participant serves as their own control. And so we are enrolling participants, taking some baseline measurements, looking at blood and urine samples for metals levels, as well as biomarkers of toxicity that we know of. We know that metals induces oxidative stress, so we can have some particular markers of oxidative stress. We've also shown that there's some immune perturbations and inflammation, and so we can look at biomarkers of inflammation. And we do 2 different baseline measurements for each participant, and then we give them a dietary supplement of zinc. It's at the RDA level, so the minimum recommended allowance. So it's a low level of dietary zinc. And they take that dietary zinc for 3 months and come back, and we take another blood and urine sample and we measure whether there's any improvements or changes in these biomarkers that we're assessing. And then they take it for another 3 months and we take another measurement. So we're measuring levels of urine, of metals in the urine and blood. We're measuring markers of immune function. We're looking at DNA damage and DNA repair. And we're also looking at zinc in diet. So we're asking people what they're eating and trying to understand how much zinc they're getting from their diet to kind of get a more holistic view of the zinc uptake. And some of the preliminary findings now, as Johnny mentioned, and as you all know, we've had a pandemic. And so our study was halted after enrolling 37 participants. We did have 6 participants go through the entire 4 sets of visits, and we have 37 participants that are in various stages of that process. But one of the things we did observe is that this is in the Redwater Pond Road community, and 37% of our participants exceed the national norms for urine uranium, and 20% exceed what we see in Navajo Nation as a whole from the birth cohort. So we know that this population in this area has a documented relatively high level of uranium exposure. One of the things we've seen, and this may actually relate kind of to your question of gardening or other activities, is that we see within a particular participant. So if you look at this bar chart, you can see these ups and downs. So when we do these sequential measurements of metals, what we're seeing is some fluctuation. So you don't see like a given participant having a steady state. We see some highs and lows, and that suggests that there may be some exposures. Maybe they worked in the garden the month before, maybe they were working in the field. We need to understand what is causing these fluctuations. I think that's important for us to think about. It provides clues as to where the exposures are coming from, but it also, from a science perspective, it makes us rethink some of our models that we're modeling in cell culture and animal models. We typically model kind of a chronic low dose or a high dose exposure. We don't model kind of sporadic high dose exposure, and that toxicity profile might be different. So we're rethinking some of our experimental models so we understand the impacts based on some of this information. Importantly, we have seen in our preliminary studies that participants who've been on the zinc for the full cycle do have an elevation in their zinc level when we measure it in their serum. And we also see a decrease in 2 markers of inflammation, which are fairly reactive markers of inflammation, IL-6 and CRP, that are statistically lower in our participants following the zinc. So that's a plus. And so we're excited about that. And we really anticipate expanding this study. We just submitted a grant yesterday to give ourselves the opportunity to look at this fluctuation more extensively by doing surveys, asking people what they were doing, activity assays, more health surveys, so that we can understand these exposures and outcomes a little bit better and expand our number of participants to look at positive outcomes. And I'm going to turn this over now to Sarah and David to talk a little bit about the community input in the design and implementation of this study. And hopefully you'll get a sense of the incredible teamwork and impact that the communities had in putting this together and making this work, because this is a huge effort. Thank you, Sarah.
Thank you. Good morning. Yat ehmana ado aninat shanant agwain hilianin zahaigi parnau jone ado kshishet ad nek etchen hizadigi e kodobi da bahashnet do lelti kok ado hompasindashnishigit o hayu. I'm gonna be speaking in our Diné language to be more specific, and the work that we do out in the field requires a lot of our language, so that's what we'll be doing. But it's good to see you. She's our main person. And we have not seen each other for over a year. Yeah. And over a year ago, you know, my husband was with me, but he's no longer.
He passed last June. So I've been concentrating on a lot of what I need to do and went back to school and got my degree, and all of a sudden I'm in graduate school with Native American Studies here. So things that progress with me. So just to let everyone know, where I've been. A could thinking zinc lot of naked hat in the other area. Height area business. Ado height oikit it. Juti up in latte. Daitis kit of the nature. Ado nishiki hanisa. No wata na ajnish the project or ya tonal ka. Ado seasonal ka, nal ka. Hane la edik at so. But adon that johito aj bitich al sali. Then the sil ka. Bigito up bito in the kit. Had been hitch in the has it's easy. Needs isla hat ipe has adats a follow. Ade na kitty benache, beto na kito. Do the house in ingi ayego and the has te. Later so had I get that go a coin now, Kate hat any git only unlaid up and nod. The Kate had any the art kahon the silk ye Eastern Agency, 20 chapters, Ebitahati ka. Akoko, Ebiyeto, deep it's baby in the Nani ha ela to Nihikato, wata, did Ayego in each in the has tetane. Ita Sani do has two anastas label, in the shil nesha, and the has kagot. The in 2005 and that was addition still consumption for the show could a call natural conseno dig at Halet or not or call cotton kahigi dig at base dot is zinc put up is ye. Halet they no con la in the up in Latin naked that any joto ahosand hundred as a nini cut or what these zinc but nini a could open sea case of atle cotton al caho at the house and a la nihikat or was that no no. A could could the usually a best of is ban sa case at hold she open sea case so. His Ishjana Alniko at ya be ka. A conda hashin such a nest a thick at near this sonny could just a cat added na a shred water pond church rock door take beats at that since the time ye now costo at apichigo. Thick at Aden al Kaha by Kaye. Dig at the Cosentire had any hinisla. A company not on it, and I see Tanahalen or Conde Shea could obey Hashne. Lady Tatazle has ta in Janoi Hatika. Adosa Nana Kaha Ionis as a land, Kodoe and that Abbot Danish God. Sayanadi Kaye ya in that up Asagi. Asa agon al kahigi yaha kwai kakot. A coco did ade dona that not all say ya kodo let's say pizza tapanaha don't let's just think over slapanaha in dol cap for all needing they just ding it adon ye bestod isn't the skis just ding dollars for all neither. A conde or hat ishpenina ed artist in over archludget that Nihisha and yes cutting doba Niheta haita nejosani dos two ayego ayay adalaya and yatasti equano a co ebony na ya cote Hanebanat ado kodeshi ya yanadaskio e naskonanat za ko kodat jo lahted nekehat ini satoyan yastio etina nishigi hot nasika aishna community engagement siningi ado apete dik at kojesani se kahege ade apito sanat leho hidden now ye histahad now ti kojet neke tahat enigi do spahos and dolesta no jo hot hanes khade auto hot etina nishigi halot ado nana asto tika penta taisuna zat o hayu sad nihin hizadi pahaten ako akwagi ya anhe be kanna nature je David ya Dr. David Bigay presentation show hashin zache hine kaha halet sit nen habes bahos dollar o jobalagana to hojon bit to hojuik it ta ako ebony na ya dik at sadiki nasteni ni hot ikitet o tinspen ya the nepaza chako hot das so pan tail now a cut ya percentage nishako cut ye look at the neka hat inito aja yenata mistoli hiki to hot belikine kaho yeta hos David dosh banane after before I go to the next slide.
Okay, the Kagi translation. Any people are gonna bizarre. Did you? Oh, you nante. Hello. The Bahwil now. Il est écrit au Tila, il non. Ban Yadil Tio. Ad neck is it. Hello. You would never send that in the shop, but you had that Tio. You could that eat Kinko. What I about hunting. I get that eating. Ako just the immediate bahane uranium ki that you never seen Asian kilpaza. At the end of that neither no. The they had a gate on that Nishan Sikia. It does smile the Acheta hot in Bahada al Bilakana to other odd natural. Ako este do el chenigi ebet bita lanes and besnas del shinla based egi ako at Navajo nation or population, the younger generation, eta uranium betatalo ako hashido nish ako as they grow older, lead out that got the killer. So uranium gidi da bit this big that betrachna das the as a yard as a bath we don't know yet. Accord to the zinc at any aber das need and according the human cell we get the joy of the DNA this. The negi nishla ko ya diskit osala daske the negi nisho damage is ko this zinki edi chon on eda hindeni seto egi in so at isto nisi ko uranium atas anigi nedo sich jota even na dibana altego ko dia the quishin Sadi hihi neyse banet aşın ki those nanat Johnny Nays he yay tibenanet hindi last week ya da hazne di ko ai ki da di ti san joni e ko ko la ko ya就da a hota be de zhi ki so da ko就第期或者有一地上难对的，就要来一样的这样的突新的这样，哎呀，哎这个呀，有看嘛是你甚至啊别的有呀多的，第别的哦也来也那那是比也还得到的 acid 快 amino acid 的是，啊都还 enzyme 的那个，这的，的那说。ne ya di protein di ya do ya di na ne di other da na ne di ko je si ba na ne ko so da sa ji is ne hilta ha ne na ha lo so do enzyme do na di amino acid ana so ko ado di ye na zi ha jo hormone de so ye ha da no e jo da ko ela ko di你是吧？哈，当年这个少个，但那这个那嘞其他的啥嘞啥，那个一边好自己的，啥那个一好像的，那好的看的，这个也提的，还个一心呢，他是这样，也提，就一个不算的，你的卡给的。sanan tega ku chinsil inegi ya ko egi bayat in halen ko ta egi iti ko tela ho
Ko di kwet ati de ya bitsani ne la te sa dan te hi o hayu ko ati na al khahi ki pitate ko ko to ati de na al khahi ki tan le sa hi go na khahi ki a sa sa di ki na halo ha hat na halana ko di kwege ya al say sa hi biomarkers e khit au bikidit itkin khadan zache baha otzi ya isnal kha bi to khat is hat at be hot to zinhligit atide o other cells khina hanana ad is anna tas la chi la kado la at na ta pije akhonde ni china aningi ajipna ta te niche ya ye sato ni is ye kinna akho these cells ya at is betasele bakon akho de niche ado DNA jo ya na to at is bekon بتان سه بتقول الاسكيزكو يه اتسيس ختان ايه so ekonanat eko ado leba hachilna unla de ta isai chun hi konit en hizadi ki bayelti o ai ta ban si ki so dai ta ni nasla kit na halo hota anit ajago yo bitnilna da ado lebik itilki nana protein igi ya chiyan bitko bitado epi daholo atse na ole ayeji neshchi atat ehegi kot da biye ako dik at lated nepe sahnet le ho de krigo shi alke kot asahandat leho ade ya presentel neshko ya hanako ahot belikista hulne o khoti ya kat laten hich ya holonigit ta ya ti pestot kijigi pi holno na ta to is it nil ilia ela biye ado de peyaje pitsento edo biye jo chojo ade ta tapiye Ado nishin tahatli hoda aja kuta tapiye. Ako kwal chadago chiyani cha ocha ano baby stahuis ko. Ado ya nlatanat ani dan linigi cho presentation mishkot ako ade natnazele tapinaga naznelo kontatahol to yego iban yatki esto ade to sabe tanati ahi yen nata asli hot eti nalkahi ki petashti ko I laat ne ke tahatini ge egot abesen da shil nesto kade en ye bestot isn't deskijo ajgushi alto besnadi kadoles eti kadijene July don't know what ada dole ko got etin al kahi ge bayinka okay, go ahead.
Question on that zinc in the uranium binds to the zinc in the human body. How much does it continue to take all of it into one area, but he was saying that it goes all different areas.
Needs is that all he had it but this is not long young needs is he had it the try hot on danish but as easy the try danish young needs is he hadah be hadah echo dig at trade software the fish by to according to Soviet and large Mahalan, the Kedo a fish by Piajan Mahalan, she did had easier to Raho. Latin with Anjunon Tanish, ye initially anti Ashoko, yan had shown. Had this in that without Ito, Ayo Hana Hatna I think I had is a creation. Kotoya I the king issue to Hakasti.
Thank you.
She's
Now, John uses on the phone, so he might ask him a question and put on. The 나이든 기대하시나 아니 저기 이 사요 우리가 거기 가이는 millions 이게 하더니 Nili short control personality for Navajo, nothing for kids, so the emotion. But you're afraid of something. You're afraid of care, the job, you're a teacher. You're afraid not to. Because the damage, crash out, not done. That's because you're the control personality. Because here, naive, that's naive. In a sequence, they number DNA damage, they because I see the don't maybe IHS can get involved with this. Just need somebody. So usually with uranium, probably. Yeah, this is something that long term.
So when the kids get it from the adult, how high are the levels? Are they the same as the adult? Are they lower? Are they higher? The contamination rate.
Well, we actually see fairly high doses in children. Some of them are as high as adults, some of them aren't ranges. We do have concerns that there are exposures in the kids that are equivalent to what the adults. There aren't any national norms for kids, so we don't have a real way to compare, kids across. And there's some concern about making adult and child comparisons, but we see enough uranium in our state and children to be considerable concern.
And we also see an increase.
Right.
So we see babies that are born with detectable uranium, and it's very few, but in some cases, the amount of uranium in babies at birth is higher than what you see in adults in the national surveys that have been taken. And then if we go back and look and it's hard to get that first P from babies. And so we have a very small number that we've been able to look at there. But as we continue looking, and this is why it's so good that we have the ECHO program to look longer. And what you see is at each year that we see these children, we get higher and higher and higher values for the group. And so, that when we started this study, there was not a general belief that uranium would cross the placental barrier. And so there was this sense that kids would be protected. And that's not what we see. We see they are exposed in utero, and those exposures continue as they develop.
Question of that. The babies, the next generation, when you got that fall, they have children, radiation to the next generation.
Well, so our birth cohort study is sort of an intergenerational study because, we're looking at, pregnant women and their children, and they, have also been living long enough. So it is an intergenerational study. We don't know enough to know what the Passover effects are. We really, right now, we're looking sort of at snapshots, what we see at this time exposure and outcomes at this time. And we don't know how much of it is carried from generation to generation, but we very much like to find out and address that. And to understand that better. But
babies are exposed when they have children.
Right. And we're starting to get hopefully enough participants in the birth cohort that maybe something that we could go back and look at histories from their families, and that may be something we could ultimately do. We have some on that as well, but we are looking at outcomes in generational.
I think the other thing that's interesting that we've just learned through both this zinc trial and the birth cohort, all of the data we had before on exposure was literally a snapshot. We would have a single collection of urine that we would look at metals in. And that only really reflects about the last 24 hours. And so, unless you're doing this long systematic collection of all urine and doing it over weeks, you really don't get what we've now been able to look at as these snapshots vary, like Deb was mentioning. We know that what we see at any single point in time may not be reflecting what the long-term exposure is. So there are these ups and downs. And so some of the people who look really high, that may only be a one-time thing. It may drop really low the next time we go back, and they may have just had a one-time exposure that they'll never repeat again. And so we're learning a lot by looking repeatedly at both adults and children. And I think that's been one of the real value lessons of being able to do these studies.
in the birth cohort also, because we're following right now the kids from birth until age 8. I mean, we have time, we can look at them over time. The same children are in our study, we can stay with them and follow them over time. I think, it's going to be really important for us to see that progression, looking at all the outcomes that we're looking at. We're looking at metabolic, diabetes, asthma, neurodevelopment. There's so many pieces of holistic health that we're following these kids. And hopefully the ECHO program will be expanded. The vision of NIH is for this to go, till the kids are 18 or longer. So we have, possibility of really being able to address some of these concerns about what really is the long-term implications of these early life exposures and these chronic ongoing exposures. So we'll have a picture of, prenatal exposure, early life exposure, midlife exposure, and all of these health outcomes that we're putting together to really understand these events. So that's what we're trying to put together. Just unfortunately, it takes time, and time is not. We wish we had. So that's one of the positives that we feel about the zinc is that we know that zinc could help even before we have some of this all mitigated and corrected. We really have positive data that supports that zinc could be beneficial to at least reduce some of these potential impacts. And so that's why the zinc trial is so important to continue.
We have Johnny Nays on the line if he wants to say something. Johnny, do you want to say anything? Maybe 5 minutes?
Yes, I'm on the line. Can you hear me?
Oh.
Yeah, the Health Education Human Services Committee. It is good to come before you again today. If you listen to, you heard all the information in regards to what uranium has done its damage on the people, and not just the people, but the environment itself. Here in Blue Gap, we're in the valley, and they're surrounded by mountains, and therefore it's just not livestock; it's the wildlife that we also have to be concerned about. And practically everything, every living things and creatures that are in the Blue Gap Valley, Touchy Valley, and I appreciate the people that are interested in all the researches that they have been doing and conducting. And I've participated several times, many times in this metal conferences. And sometimes I don't understand the research, but I always trust that they will come out ahead and find ways to possibly, let's just say, alleviate the effects of uranium. And this is just one more thing about the thinking zinc. And what we have been informing the people thus far, that they're pretty much interested in how to participate and when they will begin. And I know that just not thinking zinc has been brought up, but there's issues about their livestock also. And I think we're going to probably hear that later on this afternoon. So what Sarah and David has brought up is that even though I always think that I speak good Navajo, but there are certain words that has been very difficult that has been used, and we have been using by our people these years, and to bring those up and to make it part of our education and a part of the project, that it is our job to understand and present these information to the people with our native tongue so they can understand and comprehend. So we're on the right track, and I still have a lot to learn in terms of picking up how to give names for certain organs of the body, and particularly explaining to them about the cells and then all the DNA and so forth. We actually have to draw a picture and just illustrate to the people what the human body is made of, and what the portion of the uranium have on it. So we work closely also with the Navajo EPA and then the trustee. So we really have been pushing EPA all this time to get this thing moving. And it's, like I said, it's moving at a snail's pace. And where they left off was the water study. And what the plans that they have provided to EPA, I believe, might have came back or still under review. If somebody has that information, maybe we can you can provide the information. So we really have been pushing and to get this cleared up. I'm sure that there's a way that it can be done. So what we recommend is that the Navajo EPA and then the EPA and then the trustee, how they're working on getting the area cleaned up. And the portion that the people don't understand is that you have studies that are being conducted by UNM under different funding. So there's the Mr. Chris Shuey is pretty well known in our chapter, and he has brought in many people, professional people, experts and scientists, and provided information to the people of what they can do. So what we're saying is, are you working with Navajo EPA, or is Navajo EPA working with you, or the trustees working with you? So the question still lies is that these information researches and the data that are being gathered here, it needs to be shared with the Navajo Nation government, EPA and trustee and US EPA. And we don't want all these tests to be redone all because they want to do it, or because they want to be on record or what they have done. And we want them to share. And then also that when it does come to a point where we want our community members to be a part of the decision making, be at the table and making a decision on how to quickly do the remediation of the cleanup and so forth. So that's just my comment for the day, and I appreciate all the information that I received, and hopefully I can retain some of them and I could use some of them, but I'll do my best, and I appreciate the time you allowed me. Thank you very much.
Thank you. I guess going back to the presentation, are you doing just the urine samples, or are you doing like blood serum for doing hair follicles?
So we are currently just doing blood and urine. We are not doing hair or teeth at this point. It's something that we could consider, but it's not part of the protocol. So we're using the blood and urine for both the metals analysis as well as some of the biomarkers. So the urine is a place where we can look for oxidative stress. So metals are known to produce oxidative stress. So we can look at oxidative stress markers in the urine. And then we also look for immune proteins in the serum. We take some of the whole blood cells and look at what types of cells are present, and we look at the amount of DNA damage and
try to get a lot of information from a minimum amount of participant material. So we take a couple of small tubes of blood and each.
Yes, and for us on the committee, we discussed how in certain family lines, hypertension, high blood pressure, in certain family lines, that means this is what it's in the discussion. Do you find in your research group, your participants, do you find those same type of
Associations or
Yes.
connections, yes. So we have seen an increase in hypertension and other chronic diseases associated with living in proximity to mine waste. Our data at this point in the Thinking Zinc is not of a sufficient magnitude to really understand those, whether a person is going to get hypertension or diabetes. But what we're looking at, the inflammation and the types of immune markers that we're looking at are all well known to contribute to the development of these chronic diseases. So there's sort of the underlying cause or, contribute to the etiology of these diseases. So while you might have hypertension, you may have, that may be caused from a simmering inflammatory response, and it may impact different people differently. And we need to, in the expanded Thinking Zinc trial, we are going to be collecting more health information, a health survey, so that we can say more definitively, we can establish these associations with the inflammatory markers and the biomonitoring, put all those pieces together to understand those relationships more. But we do know that all of the biomarkers and things that we're looking at have known contributors to all of these different chronic diseases.
okay, right now, does your research, has it traced it to, let's say, uranium in the drinking water? Or is it, have you gone to, let's say, just being in the area of, in this case, at Red Pond, being in the area of the tailing pile? Is it through breathing in the air, or is it that passive intake by the skin?
Well, I don't know that it's a passive intake by the skin, but we know that there's probably intake from breathing, from dust. We also expect that there's intake from water, and we are looking again at the possibility of being intake from plants and food. So putting all of these pieces together to understand where the exposure is coming from, because it could come from all of these sources. And that's what looking at what they're looking at, and the livestock studies, the repeated measurements, getting histories of where people are, what they're doing, what they're eating, putting all of those pieces together are really going to be key for us to understand what the major route of exposures are, so that we can, or what the relative contributions of the different potential exposures are coming from. These are all pieces we're still putting together. John, you may want to elaborate on that.
There has been one case so far that we've been able to trace directly in uranium in drinking water. That was with the production of autoantibodies. That's right. Just basic markers, so that autoimmune response, not a particular autoimmune disease, but there also was a pattern within that indicated it wasn't a genetic autoimmunity, but it was an environmental induced autoimmunity, and that did link back to the constitution of drinking water. It's sometimes hard to do, for what I was saying before, that these exposures are up and down. It's sometimes hard to figure out exactly how people were exposed. And there are so many possible routes of exposure. The drinking water is probably just one in each. There probably are, people who are drinking water that's not in uranium tend to live in areas that are high as well. So I think we're learning a lot more than just the first of these studies. We're kind of reaffirming studies as well. You see a much higher likelihood of having multiple times. Saying, which suggests it's not having that impact on one disease system, organ system, but that it's a change. And that's why we keep looking at the information, how that information is levels and how that translates in the steps. Right now, I'm kind of you can see outcomes for the same context.
The last time we had one slide that showed DNA helix. And you showed sulfur going in some of the empty spaces of the DNA or to replace certain other metals. I think that basically is a good illustration. Can we glean it to where the committee could at least view that particular slide? You know which one I'm talking about.
Are you thinking on some of the ones that thinking zinc has been used?
Yes.
Yeah.
Yes. And then the other part is, let me consider Honorable Carl Slater. Let me give you the floor to introduce yourself. Did he drop that? Oh, okay.
Chair. Thank you, Chair.
The middle one? The middle one is the repair. So the other one that we have is
Oh, the other
this
one,
one.
yeah. Those two maybe. Because it really tells.
I know they're beautiful.
From his community,
So
Pachi,
we can provide all, I mean, they're all
I'm wondering
available.
if there is somebody from around the county.
So this other one.
The next speaker, May Franklin.
Okay.
May is
Right,
with
so
us,
that
and
shows
she was here
the-
several times.
That's what I
before.
was
So that's the
thinking.
good thing.
Yeah.
It shows the patterns when the added
I know Cameron is very
not as good. So
much,
that's kind of.
that's all we hear about.
Yeah, so we have all these
My
images.
mom
available.
is originally.
Okay, send them around and see if we have some.
Like this back in migration days. She got adopted and ended up about 50 miles east of Cameron. Most of our clanship people are from Cameron, Green Mountain area. And a lot of our relatives over there do talk about the uranium issues. And there's hardly any vegetation there. And so when it blows, and just by thinking about it, it's probably covered 100% of the whole land area there with uranium, because people talk about the site not being covered or not being correctly mitigated, not cleaned.
And we know that our people still live, their survival is animals. Cattle, sheep. They- And I have this Western Navajo pipeline legislation. This is one of the things that, to address that. I remember back in the day, when I was a little child, we used to go to the Ursa's Dam. It's now Boston Twitchton beats in the she don't go town. It's move the wagon backwards into the water and use a bucket and load that 55 gallons or water barrel. You could see tadpoles running around all in the water. It was nothing to us. She na tanda pikinan body close because to see other photo. I don't remember this filtration, like boil your water first and then use it. None of that ever happened. Maybe that's why I'm in good health. I'm almost 70 next year. So, but no, it was like that. And to this day, that place is still like that. The whole Cameron, Gray Mountain area.
To the city.
Yeah, it's barren land out that way. Very few vegetation. You know, the wind blows and I'll tell you, it blows. If it blows more than 25 miles per hour, all that red dust covers two cities. You can't see within 100 feet ahead of you if you drive it. So that's, I'm sure all that contamination is spewed all over the place. Travel many miles. The next time it blows, it travels another 4 or 5 miles. And it's all over Western now. To me, that's just the way I take it. I'm glad somebody's a representative from Cameron area. I also like, if you can, I don't know if you have that, Navajo translations of the show Oshaya. I'd like to get a copy of that. Just for conversation purposes, the cordillera, that's a good explanatory, very specific terms. As mentioned, there's a lot of, especially in the medical field, we don't have translation for, so we have to turn to descriptive translations. I remember working years back doing a medical dictionary, helping that, and we had a tough time trying to translate some of these. I used to work with a doctor named Oswald Warner. Northwest, that university out by Chicago. We spent a few summers out in the New Mexico region. I didn't know the area, but that's where he took us. And we tried putting some type of medical terminologies together. Pioneered a little bit, I guess, back in those days, but it was nice. I like this Navajo terminology, translations, very specific. Ani Zajo, Ani Zabe, or they now they Zajo. I'm glad that it's being done that way. Using our own Navajo language. It's more specific, it's more defining what we're talking about. I taught Navajo language for many years, so I understand how it works. So, thank you. Yeah.
Oh, I know that wishing pages. And the name to ha gine ashta. Do ta pepe na de do ta gine kamo. The gym the woman you need that. A call. I must go yeah, not in that way. Journal that is a vehicle, not so spain to us. I look up in the heat, so in the heat, so she was started to go. So it's a I need to start in that side. I just job and need to go, each channel I need to. I know that it is those other should be reason. So I think so. Let's say that. Aishi na sosiki hai shito politisho laho aishi chego kadi and then we got those four terms that we can have. Na sosiki jato bema ozio bikini nakabashante hamjon.
Allora, gente che ne ci dare i combatti, i gente, alle quelle cose gente allora so we have these training sessions. Navajo, as well as other indigenous language, their holistic language, Navajo keys. None of the gun, the Descartes, was French philosophy. Isaac Newton. How you would think and talk about things. Navajo is not designed like that. Ecco, io facevo training da NECA, di locali, non facevo, we try to communicate from one extreme to the other. It helps, I think, to have pictures up there.
Yeah.
That DNA, so.
Mr. Chair, this is Majoline. May I say something very brief? I need to get off the line to get on another call.
Who's that?
This is Majoline Begay.
Oh, that's better.
Oh,
Go ahead.
okay. Yeah, thank you for giving me the floor. Again, my name is Majoline Begay. Shehinshla, Turajini Bashushin, Hanagani Dashanado, Skahaza Dashache. And I am the program director for Navajo Nation CHR Outreach Program. Outreach program that includes STD prevention, TB control, Navajo birth cohort, and then we have another research program. So I oversee the Navajo birth cohort study. There are 4 staff involved in the research on uranium contamination from mom to child. I read my staff's monthly report where they are working with mothers, fathers, and conducting interviews and monitoring the child's growth and development. It saddens me to hear uranium impact to the human bodies. The research needs to continue so we can learn more about uranium and its impact on our people who have been exposed along with our livestock who forage in the impacted communities. To learn more of what uranium is capable of doing, we need to support more research on Navajo and within Navajo Department of Health. ko dene shil bahajo ba do shil leniki benina eya na al kahigi Jego support del idoli sen ado ko the nebakan de jahigi ilto a hotan hilsna Jego nda alka ado ultskogon hilsna hadolna dan so I just wanted to share that with you and everybody that's on this call. Yeah.
Thank you.
Thank you.
Charles Slater, based on the call, please introduce yourself.
Ms. Franklin, are you ready with your presentation?
Yes, if you can put it up.
What was it titled?
CAAHC slides for HEHSE briefing 5/17/21. Yeah, there we go. I just wanted to briefly share our project. In tech kesiki haishi botahawil ahiki isto hajo he share that ilni so she ya hashkan hat zohn shloki ani bashishing sereshki ne dash chelok atne dashnala ado le tohn lenegi little Colorado River well yehegi a da yisin hinetje in our backyard ndle Lake Kuya, Colorado River Kuyandle koho to o danil inland I akwande ani beso aden hijet CARES Act ne ton here the hasling wells production wells the hasling alcohol at ton here the hollo nate ya the Cameron Farm nhe mado nhe nalado nhe daadat zani that atahas kagi ita ya 1970s ya ta ya kita islande koho nache we betel nito nihito that eliana chinadanit lo that no ade ya the farm iki hada di losta di no the question is he kai ko e at bane kai last summer ya ta ya that iliado alla at they ta ko ai yisana nishat ela asto shido بالخيط جاكي الخيط جاء نجانكو تيليا أكو دي يا Cameron Farm Enterprise يا non-profit which that the نتا يا Cameron Ad Hoc Agricultural Ad Hoc Committee وليا بيا دي نشن دي يا Cameron Farm Enterprise non-profit كي بيتا دي نش أكو دي نتا أنا كنا خياتا إيا Southwest Research and Information Center a wishstand abadi nido nihika iche ya di the tlej dot ho chudel inigi hajot no inhat no we wanted to test it start testing it and so they came and helped us with some of those testing. Cameron Farm Enterprise, a 400 acres auto that we want to put into hay and vegetables and fruit and family gardens. Auto, the main reason is for our food security and creating an employment. So, I'm a diabetic, yeah. Oh, honey, you Navajos, we are diabetics, and so I'm looking for good food that will be good medicine for my body. Process meat that processed food I mainly eat plants. And the ones that I grow, you see shadow so the grocery store na shadow for plants, produce. Ado lay hinago. If you'll see that next slide, Allah abandoned mines on the corridor of the river. You can see if somebody can go to the next screen. Or the next slide. Hello?
Hello?
Oh, back to the map.
This one?
That one. Okay. Oh, no. Back. It's slide number 3. Right after that one.
This is slide 3.
Huh, on my slide, that one is slide 4. Okay, there's 2 pieces. There it is. There's 2 pieces. The Cameron Old Farm, but there's 17.5 acres. We're gonna do only 5 acres this year. Development days. We're getting pipelines and drip lines. This year. Next year, when we get some more funds coming in, community community gardens. So and then up the river, we have over close to 400 acres. So we want to put into hay, growing our own hay for the livestock. Mainly, we're wanting to probably address some of the feral horse issues that we have. We had a really bad drought, and our feral horses, is dead. So we just want to have some emergency feed for them. We have in that, if you'll see the bigger picture there, all those mines in Cameron. There's like 100 mines. And you'll see where the Cameron Farm area is. And around that area is 30 about 30 abandoned uranium sites. Akoko, I think we're in the riverbeds and we're fine still. It's just those drainages that are coming from those uranium mines that I'm concerned with. And I want to know, soil testing is really important in some on test case, because we need to start tracking where they are and knowing how to take care of them. Ado Western Southwest Research and Information Center in Haiko. It was stand on the need on Haiko. We had them familiarize them ourselves with handheld gamma radiation instruments. Ado height recording the data that we were getting. We also started soil the testing the soil and the plants and water samplings, and they bishnap the tohiki sto test elia. Ki height hatel into binnacha oho aheki bitsado oho aheki interpret elneheki that eheki. We needed to arm ourselves, yeah. Halate on here. Bilkehuit eniki bilkhannet do les akoi njonakoik at 18. So we have a good work ahead of us. So bon test case. Njonakon his ndahasnet do ndan hines ta. Okay, so down to I took care of that one. So go down to number 5. The next one.
This is 5.
Oh, that one's 5 on yours. Okay. Okay, that one. When we went out in the fields, gamma radiation instrument, they ADG Geiger counters, they so we did some data collection. AD map and Lake Old Cameron Farm, and we picked up some. We did all these sites. The green background at or background kid. Background is just basically what occurs naturally. Auto the red it's above 2 times or higher in background material. She put out so we're pretty good on the river bottoms, yeah. Right to the east of us, there's a dam there. A river, so it doesn't affect our fields. So anyway, but there is a uranium site right to the east and lay past the dam out to the east. The uranium site. So we keep track of that really good. And also, Otto, if you'll go to the next slide. Okay. A few years back, I saw NAU students, they wanted to test our sheep, and I gave them 2 of my sheep, and they found out that there was uranium in the elevated uranium in the organs of my sheep. That was compared to I think it was St. Joseph, some sheep down there. And mine was more elevated than those sheep should don't need. So that led me to my concern. I show you what I grow and what I eat. So I collected some plant parts. They the roots, the leaves, the stem, and then the produce itself. My watermelon, my squash, my blue corn, and my white squash, my white corn, and my watermelon. Plant parts. I collected those and sent them into University of New Mexico to have it analyzed. Because of the pandemic, students haven't been in their labs. I haven't gotten any of my results. Hopefully, after they get green lighted, they'll be back in their labs and we'll hear what exactly our soil has in them. Yeah. So I'm excited about that. I'm really grateful that Dita 1970 because I have diabetes and other things. I want to know, is it the plants the food that I'm eating? And if so, then I need to pay more attention to my food. And so, so we have been doing a lot of searching here at Cameron Farm Enterprise. That's an idea kid. I appreciate this opportunity to share our project with you at this time.
Oh, yeah, thank you. Ms. Franklin. She will. Thank you. Miss Elaine. Have you collaborated with Ms. Franklin on, for myself, the alfalfa has really roots. And I'm wondering if alfalfa would be bringing something similar to the study that you did.
Yeah, so we have like a few plant samples in 2019. We compare the nutrition of alcohol there. Like we was a company, something like that. And at that point, from the fact that from where it was collected that plant, we did not detect uranium accumulation in the roots or the area part of the plant. And for now, actually, these samples, food and vegetable samples that were presented here, that's why we have them in the lab in UNM, and we hope that right now, like coming back in September, to be able to process and analyze the samples and look for any metals.
Thank you.
Yeah, so thank you, Franklin, for collaborating with us on that. Really appreciate this collaboration.
Okay, thank you.
So we have some burritos that have come in and thinking we might have lunch, and after they eat, have Edie and Bertha take a few minutes to update us as well.
May, thank you so much for participating. I'm sorry that you couldn't make it in, but it was really good to have your presentation. Thank you.
Saying that it's too low. It's up to 100 for the phone calls. Okay.
Yeah.
Zoom call as well as for the folks here.
Oh.
In the room where we're at.
I'll let them know.
So tell it, go ahead. *6.
Guys are becoming pros.
He's on there, but
Okay, so what we'll do is we'll take a, what, 40-minute recess? Eat lunch and do small talk. Thank you. So we'll reconvene at
1:20.
1 o'clock. That's 20 minutes. 1:15, we'll reconvene at 1:15. So thank you.
Okay, did you say 1:15?
Hey, there he is. Introduce yourself.
Okay, never mind.
So go ahead, introduce yourself to the folks on the call and the scientists in the room here, researchers.
Yeah, thank you very much, everyone. I apologize that I was not able to attend in person, and I appreciate getting updates via telecommunication. Adona initially a ke ani she sontene bashchin tina jini dashiche ada sontene dashamela she Carl Russell Slater dashajene listo kuj des ahet nasha. So my name is Carl Russell Slater. I'm Kiani, born for the Jewish people, and I represent 5 chapters in kind of like Northern Chinle or Central Agency, and just really appreciative of everyone's work and the communication that's open with the council right now. And I'm from Round Rock, or kind of blue pointed mesa that is right here in Round Rock. So thank you very much.
Thank you. Thank you, Satilla. Like I said, we'll go on lunch break. We'll reconvene at, let's see, 12, yeah. Okay. 1:15. Okay, we're on recess. Thank you. Yes, sir.
So these ones are just
Yeah, well, let's plan another time. Yeah. I just heard the cats. That's my skill. I used to. We had a great. So, yeah. No, it's taking. I guess 20, 30 years since I started. Yeah, me too. So far. We're so- And it would be.
So they're. These are part of, so they're part of the friends that have today. So they make their own degrees.
While you have it. Wow.
David.
I was gonna say, I'm surprised they gave it to And that's what they bring some check up to make sure. So one for, it's just like the now. But then they can look like that. Sort of follow. There's so many.
You guys don't mind signing in?
And it was really early. I know,
Tradition of all the spiritual side. I did.
Yes. There's no meat. So, yeah, yeah.
No.
Adjective.
I'm on my way out. That's what they mean. The reason why is that there was an herbalist,
We can cure there is ways traditional ways on the spiritual side. Okay, but you get research.
Yeah.
There's so much of the day.
Yeah.
They know they can combat it. They can. Quite honest. The thing is now, start out by kind of says clear. The measure.
No.
Oh, it just makes me think that. There's people that really push me. Even though you're just missing by faith, right? Otherwise, I still can't. Because there's a cause, there's a cause, and there's a cause. That's what they should be. Right.
Yes. Yes. I think the best for it is, another house with like bands, they have like Peregrino, yeah.
Fancy.
Yeah, kind of, it's not just coffee cups. Yeah, I think there should be enough for you, anybody wants to know.
It's not matter. Is. But still. Matter. Not a regular classic science.
Spiritual society,
Yeah, they had a 2 o'clock flight with my brother.
How could this stay there? You know, it's some kind
People that go to the military. My idea, I think, now, your sometimes what they closest to. They have. PSP. So I just resigned. I don't know. I don't know. I think about those things. So I had to call. Yeah. It doesn't necessarily mean it's. Going back is never happened actually. Not that scientific lab. These are able Third has baby cousin. See that? You know, that's what it is. See what else? You start breathing. Sometimes you scare me.
You won't let me go. Hold on up. So, do something and then you get down. So keep going. Your body will heal itself, and so it's not letting you. If your body's not healing itself, then you have to go mind over matter. Either the mind over matter.
Yeah.
So you're supposed to water. You're supposed to have certain water days. I watered it. But I did mulch. So what I do is I plant. No.
Then just leave it different. Okay.
Upside down, inside out. Amy, can you play out?
Oh, yeah, yeah.
That's something like that.
Miss Michelle Trey. I think she loves that for about
I'll see if she's on.
Taking one. So.
I wonder if we can. Oh, it looks like it's still connected. Shall we start again? Um, So. Okay, I think we're gonna start again. If that sounds good to folks. It looks like we have a lot of people signed in. Okay. Okay. So if it's okay with the committee, we were thinking of having our colleagues from Redwater Pond Road talk next. Is that good? Do you guys want to come up here? Or? I think you can hear better if you're up here.
Where is the mic? Where's the mic?
Where is the mic? That's a really good question. Deb, do you know where is the microphone here?
I don't know where the microphone is. I was just trying to talk loudly. I think people could
What's
hear
this,
me.
do you think?
Maybe.
Johnny, it's Chris. Can you hear me?
Microphone that's the logo, the round thing. You just push the green button. Yeah, for that, but I don't know what these are.
Try saying something and let's hear if we can hear you.
Uh,
Why don't you say something and we'll see if we can.
Yeah, we can hear you. Can you hear us?
Yes, we can hear you guys. Okay.
We can hear you.
I was gonna say that when people step
Good
away from the mic.
afternoon. Can you hear me?
They can hear you on I think you get picked up by the computer mic here. And so that goes to everybody else who's on the call as well. Okay.
Okay, I think we're getting started.
Good afternoon. This is Edith Hood from Redwater Pond Road. I was given a few minutes to talk about Redwater Pond and its issues and concerns. I'll just give you an update. As you all know, Redwater Pond is 12 miles north of Church Rock, and I always say that we're very famous for that spill that happened back in 1979, which contaminated the waterways down into Arizona. The Redwater Pond Road organized back in 2006 after helping with the sampling from the haulage roads that took the ore into Grants, New Mexico. And from that sampling, it led all the way back into our community. And here, the grades the ore had were jumping off the charts, and that's when we finally got notice about how high these readings were. So since then, we've been trying to get the government and the responsible parties to clean it up. We have advocated, like I said, for the wastes to be removed from the community and take it to a disposal facility nearby, and to restore the land
and take care of the people's health and take care of the Mother Earth's health also. We have appeared at countless meetings, hearings by the EPA, and of course, like I said, we've been to the Waxman hearing in 2007. And at that time, I remember Mr. Waxman himself asking people, where have you people been? Where are your trust responsibilities? There was EPA, NRC, DOE, and then of course, I remember PHS was also mentioned. And I always wonder at these meetings that we have together, where are they? PHS, IHS. They need to be at these meetings because it has affected us all, our health. And then of course, we're dealing with EPA almost on a daily basis. And so right now, I don't know if you guys have heard of that DEIS, the Draft Environmental Impact Statement with the NRC. And what that and what in there says that General Electric is trying to get a license okayed from the NRC to move that waste from the land to about 1 mile down the road. Because the Navajo boundary line is just right in there. Then there's the trust land, the state land. That's what we have to contend with too. And so we have the NRC on this side, the mine, which used to be United Nuclear. AICI. And down the way, we have the mill site. We have the Kermagee, which became Rio Algum, and then it became Quivira. The one that's on Navajo. So right now, we're also trying to tell EPA, can you clean this up all at one time? No, we're just dealing with this one right here. No. So they're just going to take it down 1 mile. And so we're trying to tell them, take it off Indian land, take it off Navajo. We didn't ask for this. No. When they do take that waste down about 1 mile away, all they're going to do is put it on top of what's already there. And we talk about this. We have those floods during the summer. I don't know how, but it's held on so long. There's 3 drainages coming in together. And it seems like every time we do our July event, it always rains. And you could see for yourself, so that water that always runs down, runs right by that tailings pond. That's what they call it too, the tailings pond. And what if we have another accident like the one that happened in 1979? And if you're just going to put it down the way, 1 mile away, how are you going to cover it? What protection is it going to have? With this DEIS, the draft statement, I shown the Navajo tribe, well, Mr. Nez and Mr. Lizer did a letter for us too, also to NRC to say that, take it off Indian land. And then So I think the health aspects of this issue needs to be talked about. Just on Hidaya, this like all across Navajo Nation, and at the same time, when I say that there was those 5 entities that were brought up on this case, it makes you angry. So in there, I don't know, but I always include the Navajo tribe. I said, you guys signed the paper, you let them loose on us, never bothering to come back, but you did to the people and the land. And that's what I say. So this committee, I'm glad you're here to hear us out. Ashon, it's good to come to these meetings and let out what you want to say. And I thank you very much for being here. Ado Anzan Holjij. So a lot of our children had asthma, breathing problems. Ado Andahas craving like cancer, and then respiratory issues. Now we just want to off Indian land. Akwishi Nihizad Beni Kadocha. Akon so hasti shehat.
We may have studies for the people around the mine because they suffered for so long. And we need a long-term protection. I know the livestock really need to, so they need to test the plants and the water around the uranium mine. So, we were kids when this started. I'm 75 years old. I was born there. Oh God, beating this children that know. And we have our needs in the crash. Even now, we're trying to hold on to the land. We need help to get support from all areas, especially with all the people within the impacted mine get together and discuss all this together. Maybe that way it'll work from all the chapters. So that's what I think, if we all get together and discuss this thing together, talk about it, maybe that way they'll get it off the Navajo land to where where it's supposed to go off the Indian land, the Dino. And we've been talking like this since 2003 at the Navajo. So although Kadishchi, seems like we're still in the same place. So we all need to get together and talk about this. And from the Navajo tribe, although from the health department. So that's what I think. Although we're trying to protect our land for the health of the people, the plants, air. That's what we're trying to do. And since 2009, we started a walk for this uranium mine. I know we have a lot of people that come around and take notes and stuff like that, but we don't hear from them back. But they have observed already seen, so we want to get those information back. So and then we have people that come from Mongolia to come and visit us too. And we try to invite people from all over. So please help us to get all these things off, this uranium off the land, because we're sandwiched in between these two mines. And to protect the environment within the Navajo land. I know there's a lot of uranium, about 540 abandoned mine. So we Navajos need to get together and discuss this all together and do more to get this off the land, on Navajo land. So that's all I'm going to say.
Thank you. EPA President, so Chief of Staff. Committee members, do you have any questions? Up to us. What do you see as a logical step? How this committee could best be to be an advocate for our citizens? The Redwater Pond.
Big question. I've watched, and we now have 4 generations of that community that have lived under the waste from the largest uranium mine waste pile in the world for a period of time, and certainly the largest in the US still. This situation has been devastating to watch. I've watched that community try so hard to get response and to get support for something that will keep them together. When I started interacting there, it was one of the tightest knit communities I've ever seen. And a lot of people have had to move away in that time, and yet they come back. You know, the community, the core of the community is still there. And I think anything that can be done at the level of Navajo Nation government to support their efforts in trying to have a response that responds to their needs and their desires to stay on the land would be excellent. They've been trapped in a bizarre situation where, I mean, they didn't talk about this today, but they designed a whole community that would relocate their community on the other side of one of the mesas, still on their traditional lands, but away from the direct impacts of that mine waste. And EPA can't do that because of the way their legislation is written for CERCLA. They have to have the same infrastructure that they had in their original community, or they can't relocate them. And if there's any way to impact that decision and any way to get that legislation changed in some way to allow what the community has wanted to happen, I think that would be an amazing advancement. I think it's really coming together and listening to what they want to do. Their generations are still, even the ones who have been relocated, they're still part of that community. They're still part of those families. And it breaks my heart every time I hear this story and see the story and spend time in that community. And the way this situation is now, a lot of the work that we do can't go on there because we don't have access to the waste. We can do the clinical trial there, which is something that makes me feel good because at least for the first time, we can offer something that has a potential to do some good and provide some relief. But, I think they can speak for themselves much better than I can. I've seen the frustration for 20 years now that I've been working on, 21 years. And I would love to see a cohesion between Navajo leadership and the community to work at a federal level and see if there's not something that can be done to resolve the situation. I mean, it's heartbreaking to see. If anybody has not gone there, I would highly recommend going and seeing what the situation on the ground is. Did you guys have any other recommendations?
I guess the main thing is, in the Bikia committee with Speaker Seth Damon, we held some hearings. Like at Crown Point, and that's where relatives came to make statements. We also went up to Shiprock. And I guess we in a way, we just let it go in one ear and out the other. And so now this is a very good reminder that we need to pick up this issue again, and this time do something with it. Right now we have a Congress that has we can affect what Congress does to amend the legislation. That would be one of the things that we push forward for. In, I guess, not in separate boxes, but to put it all in one box. That you look at in the camera area as well as the area up in Cold Red Valley. That would be something that we will look at. I guess the base of and what I see as a real good factor is the results of all the research that you folks have conducted as the basis for taking action. Thank you.
Thank you. So I'm going to move forward and talk a little bit more about the the birth cohort study. And I guess one thing we'd like to also acknowledge is that the reason the birth cohort study started in the first place is because of situations just like you heard about. And when we started the first Janae project, oh, I hear nobody can hear me. I will try and speak. Okay. So anyway, the birth cohort study initially was the result of the Waxman hearings in 2007 and many Navajo communities speaking to Congress about the need to do research to answer their questions. And as we did the first DNA study, one of the questions that came up most often was, what is this doing to the health of future generations, to the health of our children? And it was because of those continuous responses that we put that forward, and that many of the communities put that forward to Congress, and resulted in getting health studies added to the 10-year, not 5-year plan initially, and then ultimately the 10-year plan, and the focus of those being on children. So I had the slides for this here a minute ago. So what I want to share today, we've done a briefing in the past on the overall findings that we had. Whoops. Hold on.
You have to share the screen.
Ah, okay. Thank you. You'd think I would have figured this out in 14 months, but some of us are slow learners. Thank you, Michelle. So when we last did a briefing on the birth cohort study, the findings that we talked about then are consistent. We are still seeing the same thing. We have not been in the field through COVID. We hope to be back in the field in July to start resuming the neurodevelopmental assessments. We have been able to do a few of those remotely, and we are still seeing what we reported at the time that you were here last, which is the delay in language development. One of the things that really concerns us with the impacts of COVID is, you've heard repeatedly that one of the things that we see linked to the uranium and metals exposure is dysfunction in the immune system. And so now we have just gone through a pandemic. We've seen very high rates of disease on Navajo Nation, of infection. And we, of course, wonder, how is that related to immune dysfunction? And Daniel will show you some of the data that we've come up with working as a combined group with IHS and with University of Arizona colleagues and with NAU colleagues. And we've been in Montana, actually in Berkeley, and we've had a working group that's really tried to sort through what were some of the main risk factors. Can we identify that? And I've spoken with you early on about some of the things that might have been risk factors. We haven't been able to make a lot of progress on that yet, because we're still working on data sets that are at a scale that are too large to really refine those predictions. So, you know, we're kind of at a standstill there. But some of the things I'm going to talk about now are more the follow-up. So we've gone back and we've looked at the women who were in the birth cohort study, and we've looked at their children, and we've at that level tried to get data on rates of infection. And within the information that we have on those two generations, seeing if we can drill down a little bit better there and see what some of the risk factors were in those groups. And more importantly, to see what we might anticipate moving forward. And our concern was, as we watched our staff and saw the stress that people were under, we were very concerned that if parents were really stressed and kids were really stressed and everybody was isolated, that was likely to have an impact on development. It was likely to change parenting styles. And then as all of the Black Lives Matter protests started and all of the discussions on equity and discrimination and disparities accelerated, we thought about what kind of impact that would have. And was that going to make for even greater stress on Navajo Nation than in other places, because you'd see some combined stress from the high rates of COVID and the discrimination. And so we got together with a couple of other communities, a couple of other cohorts that were part of ECHO, one working with the Sioux and with rural populations in South Dakota, and another working with urban Black community in Atlanta. And we thought, let's look at this across all of these cohorts and see, did everybody have the same response? Were there different responses? What can we learn from that? Are there things that made some communities more resilient than others or more vulnerable than others? And so I'm going to go over what we know from the data we've collected so far. We don't have the comparative analyses yet, but I will certainly report that back when we get that. Need to figure out how to make my slides go forward. Oh, yeah, there we go. Thank you. So first of all, the most interesting thing we found from everything that we were seeing, we anticipated the people who had COVID would have much more stress than the people who did not. And much to our surprise, it was exactly the opposite. So we had relatively high rates of infection in the people in our study, but the people who actually got COVID actually had lower levels of stress that they reported than the people who didn't. And we're thinking about two things that might have, when I first saw that, I thought, well, we messed up somehow. We must have collected the data wrong or asked the wrong questions. But when you think about it, there is a lot of stress associated with worrying about getting COVID. And in some cases, you could imagine that you now know what it's like, and that stress kind of drops down a little. The other thing that I think is probably even a bigger contributor is that when you watch your family and friends being affected, it's very stressful on you. And I think that's part of why we saw what at first looked to us like a reversal in what we expected to see. So the graph on the left, these are the turquoise bars are the people who actually were diagnosed or told likely to have COVID. The red were not. And so, I mean, there's a lot of overlap, but you can see that the highest stress that we see is in the group that did not have COVID. And this is the same comparison, but looking at where the children had COVID. So then we started looking back at what were the rates that we saw. And in our moms and caregivers, about 22% of the people in the study that we've gotten to talk with so far were positive for COVID, or excuse me, were told by clinicians that they were likely to have COVID or had COVID. And 8% of our children, and if we compare this to the other cohorts in ECHO, it's only 3% in the other cohorts. So we had substantially more children who were impacted by infection than the other cohorts in the country did. And the concern is that we know that there is a pretty high rate of symptoms for long COVID, or long haulers disease is sometimes called, or late occurring effects of COVID. But these kinds of persistent effects that come up 5 months, a year after the original infection is cleared, we have no or very limited data so far to know what that looks like in kids, or what that looks like on Navajo Nation as a whole at this point. And so one of the things that we've also done is gone in with, how many cohorts, Deb, ended up in that? About 14? Something like that. 14 other cohorts from around the country. And we've asked for funding to do 3-month follow-ups going forward so that we can track whether people are getting over the initial infection in any of the long haul.
In kids.
Hmm?
It's in kids.
In kids, yeah. Whether they get over the initial infection and have additional symptoms or not, whether they have the kinds of inflammation that we would be concerned about, what kind of antibody responses they have, and if those are persistent or what the time course is. Do they stay stable? Do they drop off? So that is in the future. We should hear about whether that will be funded or not by the end of this month. So our questions again were whether or not the metal exposures suppressed immune function. We don't know that yet. We will be able to get a little bit better handle on that if we can do this follow-up. Did COVID increase the stress in the caregivers? And did that combine with any other discrimination variables? And will there be long-term impacts? So what we know so far is that we did have significantly lower stress in the people who had or whose children had COVID-19. And the people who were in the higher stress group, it was related to having lower infrastructure, lower informational and emotional support. So we asked a lot of questions about the kinds of stresses that people had, whether they had family that they were living with, whether they had that kind of support, whether they were able to pay their bills, whether they were able to keep their jobs. Those kinds of things would go in the infrastructure side. Informational support, if they had the services that they needed, if they had people they could ask questions of, that they could get information from. We also saw a relationship to the caregivers with lower rates of education. So the caregivers who had high school or lower in terms of education tended to have a lot more stress. And we also did see interaction with discrimination that people reported experiencing. So what were the main things in terms of the informational, social, and infrastructure stressors? Early on, I know everybody was concerned about access to clean drinking water. That was seen as a really major issue. I can tell you that in the work that we've done looking at the water access, that has not borne out as a major risk factor. Now, it did not get mentioned by the people that we looked at in this particular survey either. One thing we don't know, though, is whether the lack of concern about getting access to clean drinking water may have also been offset by the work of the working group to make sure that the clean sources of water were distributed through the chapters. And that was part of that water access group that I mentioned earlier. This one kind of surprised me, an inability to access mental health services. And I didn't realize that that would come up as such a high risk factor. People really, I think, recognized that they were very stressed, and the fact that they couldn't get access to services to help with that stress, I think, excuse me, my phone just started ringing in my ears. Let me just shut this off. What also was associated with this higher level of stress was increased conflict in the home and harsher discipline, harsher self-reported discipline of children, which makes sense. Tempers start fraying and the levels of stress go up. And as we were concerned about, sometimes the kids were the ones who got more severe discipline. There was a lot of concern about lack of access to enough or to healthy food. And some of this just in the initial analysis that we've looked at, the initial summary of data, I think some of this is related to the fact that a lot of people lost their jobs and they lost their income. And I think those were a lot of the people who were very concerned about access to food. Also, a big increase in children's emotional problems. And this is consistent The studies that I've seen that have been done and reported so far mostly have come out of England, where the schools started looking at the kids as they came back and looking at what kind of problems they had. And they report a lot of need for emotional support, that the kids from being isolated had lost a lot of the ability to deal with those kinds of emotional problems, that they saw a lot greater need for mental health support for the kids going back to school. And interestingly enough, in the British cohorts, the other thing that they saw was real impairment of language development skills. And of course, that's really a concern for us. And we're very concerned what we're going to see when we go back in the field in July. And again, this is something that isn't real surprising because kids were at home all the time. If people were wearing masks, you lose that interaction with verbalization, you lose watching people's expressions, and you lose watching mouths form words. So I think we'll learn a lot more about the impact of that in this cohort when we go back into the field in July. Parents reported a lot more screen time, both for themselves and for their kids, and increased isolation as a result. And also stress because of family and friends moving into their homes, often also related to loss of jobs. So the lack of access to clean water was mentioned, but it was at a lower level of concern than the first bullets that I just went through. And we've now started also assessing parenting and looking at how effective parenting has been through that period. And it does appear that, and parents report being more lax and either more lax or overreactive. So big swings in how you respond to seeing, to parenting in general and watching what your child's doing. So right now we've only got, I think about 178 of the moms in the study assessed. So we'll continue that and finish assessing the moms in the cohort. And then, as I mentioned, we'll compare with other populations and see what we can ferret out. In some sense, you know, I think there's going to be a few resilience things that come out where, because of in spite of the fact that the emotional support was listed as a problem, I think for a lot of the people, it also was a strength. And that's the kind of fine tuning that we'll be looking at as we move forward with this. And then hopefully, again, we'll be able to look at the neurodevelopmental impacts in July in a little more detail. And then if we can get this other opportunity to follow up every 3 months, I think we'll have a much better understanding of how this looks long-term and what the impacts that we have to be prepared to manage in the future will be, and how we can best support families and their kids in development. I mentioned in terms of the overall work that we've done on COVID, we're continuing the work with the IHS Access. Daniel's going to talk to you next about something that we've been able to do that we think is going to be a really important resource for the council and the committee as well. And in terms of passing information on to future generations of leadership. And then the work that we're doing with the University of Arizona and the other universities in terms of trying to really sort out what some of the factors were that contributed to the sensitivity to COVID infection. We're continuing to work on that as well. We've had a little bit of a hiatus, a little bit of a break on that, and we'll be starting again in the next couple of weeks, actually. We're starting those meetings again. But what I want to turn to next is having Daniel talk with you about the water database that we've been able to develop. One of our concerns has been, especially in situations like the last election, where we had ongoing relationships, pretty good ongoing relationships with a lot of people who were on council. And there were so many changes in council that a lot of that history got lost, and we've had to make sure that we can rebuild it and make sure people had access and knew what was happening. And so we've talked a lot about what can we do to make the work that we do and our research findings more accessible, so that when new people come onto council, there's an opportunity for them to get summary information on their own and to look up information as needed to make decisions and to inform decisions. So Daniel's going to talk to you about where we stand on that right now. Does anybody have any questions on what we have so far on the COVID data? Okay, turn it over to
There's three
Daniel.
of us that on the committee that experienced the COVID.
What was, I'm sorry?
There's three of us that experienced the COVID. We're all nodding. on some of
Yeah,
this stuff.
make that 4. Me too. It was not fun. It still is not fun.
Yep.
No, I definitely appreciate the long-term impacts. I'm still trying to deal with getting lung function back, so.
Yeah, my concern is more with the children. There was 3 individuals that submitted legislation to address the trauma that children are going through. Because we don't know. That doesn't mean they got COVID. It's just that experience that they went through, their loved ones, their parents, or whatever. We always say that now the younger people, awareness is still developing, their
Yes.
minds and all that. So how is that going to affect them in the long term? They don't get the counseling that they need, the attention that they would need at this time. And we pushed it to see if there could be some funds put aside for this individuals to go, hire people to go to the schools and work with the young people that have that experience. And I think we still need to do that.
Me too. Yeah, from what we've seen, and this is just very minimal data at this point, but with ours and what we're seeing coming out of other studies that people are doing, I think the impact on kids is going to be pretty substantial. Just that disruption in your day-to-day life during that period of time. Even if nobody in your family was impacted, to not be able to go see grandma, to not get any public interaction, that's huge.
Yeah, even yourself, you don't know, like after I got better, I can still, it's giving me problems that's going in my lungs and my heart. I just don't know if it'll heal or if it's going to heal. So I just don't know.
I totally appreciate the way you feel with that.
Mhm.
No, I've lost about half of my lung capacity. Scary. And you don't know where it's going to go. So no, I appreciate what you're going through. It's not fun. Yeah, and then you hear that it doesn't exist. I don't agree with that. No, but I think your idea about starting early to get some sort of counseling services even in the schools is really bang on. And that was what England was reporting too, because they were a little bit ahead in terms of the trends. And so they started looking as soon as they opened up at the schools. And the teachers were all reporting we need a whole lot more mental health support. And David, I don't know, did you want to say anything about just some of the work you've been doing too?
I understand the question.
Did you want to say anything about some of the work that you've been doing in response to COVID? And just supporting families and stuff? You don't have to.
Well, just, the basic information that we've been sharing as far as COVID is concerned. this basic information has already been presented. Mostly, people that we ask for anxiety, worry, fear that anything can happen, with the family, and so they just want assurance that some kind of assurance that if you take care of yourself, you can be infection free. As long as you can take, as long as you take care of yourself. Those kind of just basic information. Just talking to people in general. So this, a lot of this information is already coming through the news and it's coming through the radio, and so when you talk to people, all you're doing is reinforcing some of those information. That's about it. As much as I know.
I'm Nick Katobi.
To explain some of these things in Navajo. So, I think the doctors and the medical community and the scientific community, we're learning as we're going along. We don't know enough about COVID. We don't know how long the lingering symptoms are going to go on. Nobody really knows. It's the same thing with Navajo. Navajo's COVID. They're now experiencing long-term lingering symptoms. But though not is one thing, you caught a virus. The spot is body still COVID still in your system. That was it's not that much. Until you still in your body. It's how now we think about it. Still in your body. So if it's just a headache, memory help, still in your head, still in your body. Explanation is all we've been explaining to people that do ask. Is she doing this? I'm not sure. As we go along into the spring, summer, and we'll never know. I know that some now resort to spiritual feelings. Taking a little piece of the concept off of the sun. I think we're all into this. Navajo on the Navajo side, spiritual activities, fighting something, herbs, people experiment with different herbs. Sure, part of former president Remember, it's 1800 Earth, not the four, to be the most effective. People are experiencing different things. The other thing too, you know, we're all mixed different. So, we're going to experience both in different ways based on it. Something based on it. Health, condition. On the Navajo side, which people are already, we have these three conditions. Which one is that? You know, these three conditions, which Mars, these three conditions. So, Western medicine, what they're saying is pretty much what the traditional people are saying. Commonalities, exchange of information. It's an ongoing discussion. You know, nobody has an answer right now. We're just into over a year of this symptoms. And also not be able to learn more, know more by the end of the year. So I think everybody's looking for a cure. You know, I think everybody is any way to find a cure right now. Because a lot of these lingering symptoms, they're not going away. People's experience, you know, this symptom, you know, well, these lingering symptoms, well, they turn into something else. It's, you know, it seems to be the fear. You know, well, they turn into like a heart disease. Well, they turn into, you know, a liver disease. So that's the concern. Nobody knows. The anxiety, the stress level, just thinking about it, taking its toll on people's mind and worries. And so it seems to be where things are at. Oh, hey, oh, just cut it out there.
Come on. So this is.
Okay. Thank you, Chair. Very good discussion. Makes you think the COVID-19, I think it affects everybody except me.
And how did you do that?
I tend not to take it or let it absorb in whatever school. That was a person. We both didn't get it. She's going out of her mind. She didn't get it. It's good that she's protecting herself. But my stress comes from being sprayed down when I'm going that. I don't leave my toes outside. I'm not coming in. Things like that. That's the only stress I have. But I tend not to let it get. And I think it's a good thing. I don't think that's I knew I took care of myself. Said sanitizers. If I'm going into this with this crowd of people, I had a little sanitizer in my pocket. respects social distancing. Everything. I think I think gets me to believe that I'm okay. As long as I'm self-aware. But I think fear of this unknown thing out there is, yeah, because we don't see it. That's the way the Navajo people look at it. It's an unseen evil out there lurking among us. Jump on the side. Just talk about it.
You know, you make great points though. And yeah, that's part of the, when I talk with clinicians from around the country who are working with long COVID, there's a whole range of things, and some of them really are just that people didn't exercise as much. People got more stressed, and that it's not a result of the virus, but of all of these other changes in behavior that happened at the same time. And I think that's part of the deal now is people trying to sort that out. And in some cases, they're finding the treatment, it really is things like increasing exercise. And people who were infected don't seem to be able to sort of push as hard as they used to do that increase. And so there's a lot of talk about just go really slowly, but a year of being inactive is a long time. And being inactive with stress is a bad combination in any case. And so, yeah, I think a lot of people are struggling with exactly what you're talking about. How much of it is personal reaction to just the pandemic as a whole? I mean, in some ways, it affected everybody, whether you were infected or not. And so, yeah, sorting out what was directly the result of the virus, the way people don't look at it, it's going to take a long time. But you make great points. Watch your skin, you don't want too much stuff. Thank you. Daniel.
Great.
Yours.
All right. Thank you all. So as Johnny mentioned, I'm going to talk about database of water quality at unregulated wells that is the result of a large concerted effort from a lot of people. And it's been many years, and it kind of got wrapped up into this mandate of the Water Access Coordination Group and has some implications outside of that, most certainly. So as I said, this was a large effort started by Chris Shuey and our colleague Joe Hoover. So there was really no centralized repository of water quality data at unregulated wells in one location that can be easily accessed. And so what they did was they took data from about, what was it, 28 sources. Oops, I'm trying to switch the slide here. Okay, right. So there was 26 public sources and then two private ones. The private ones are the Dine Project and NBCS. And then they have these, but sometimes very historic records that date back to 1905 for more than 1,000 wells. And these laboratory analytes or results total close to 73,000 individual records. So what you see here on the right, it's really small, but that's essentially to give you an idea of the framework of this database that we have. So we have information on water at individual wells, information about mines that they're close to, and all sorts of other pertinent data. So the first thing that we did was we cleaned those 73,000 records and converted the results either into average or median concentrations. And that was really based on drinking water and water chemistry standards that are set by the EPA and just other sort of industry scientific norms. And so I'm putting together this website, and it's not published yet, still trying to iron out some kinks and get some feedback from people. But the first thing you'll see is this map of the Navajo Nation. And each one of these dots is one of the wells for which we have data. And they're kind of colored by the intended use, if that data is reported, right? And you can see a key down here at the bottom. So the next thing that you'll see is right below that map. If you'll scroll down, you'll see this little dashboard where you can observe the actual distributions of the data. You can look at relationships between them, and using these drop-down menus, you'd be able to choose different metals or water quality analysis of your choosing. And finally, as you filter the data, this table below that will populate. So you can actually download that, look at results from individual wells, and just try to kind of help the understanding of what's going on in these wells. And so to that end, the target audiences are people just like yourselves, policymakers, other researchers, and also importantly, the public. And that's something that I'm still working on, is trying to make this website optimized for cell phones, for people who might not have, desktop computers. So there are a lot of ways that you can interact with this website, and I'm just going to show you one example that may be interesting here. So for example, if you're interested in looking at wells where the levels of arsenic exceed the maximum contaminant level, or MCL, which is 10 micrograms per liter, you would just brush this bar graph and select the values that are greater than 10. And so then the map would automatically update with the 217 wells out of our, I think there's 1,116 in this database, or in this particular map. So 217 of those exceed that maximum contaminant level. The other thing you can do is you can change what appears on the map. So you can change the map itself. You can also add cities, the major cities across the nation, and also uranium mines, and make some inferences. So for example, what we see here is that these mine sites are red dots, and you can see some kind of similar rough spatial patterns between the distribution of mines and the distribution of wells that exceed this maximum contaminant level of arsenic, with the exception of here in the Fort Defiance Agency. Similarly, we can look at uranium. So in our database, 79 of our wells exceed the MCL for uranium, which is 30 micrograms per liter. Yeah.
Sorry, I guess the people on Zoom couldn't see the slides.
Oh, no.
How about now? Can they see it now?
Yeah.
Okay.
I'm so sorry about that, everyone. I'll be sure to share the slides with the people who are remote. So if we're going to look at uranium exceedances, which is 30 micrograms per liter, 79 wells in our data set exceed this value. And again, if we overlay that with the uranium mines, as you can see here, there's a little bit of a spatial pattern. Again, it's not really explaining what's happening in Fort Defiance Agency. And so I just want to leave it at that, but mention that there are a couple of considerations. So the first is that this data set is by no means a complete record of all of the wells across the Navajo Nation, right? So especially in the New Mexico side, where there's not very much uranium exploration, or there wasn't historically, there also isn't a very robust historic record of wells out there. So in an instance where here in the Huerfano chapter, where it says that there's one well, that's not necessarily true. So, and then the other thing is that since this website will face the public, we can't share all of the data because there are a couple hundred wells that Chris Shuey and his team sampled under projects under the Dene and NBCS projects that we can't share. So one of the workarounds will be that we can have two versions of this website where people who are allowed to look at it can sign in and see all of the data. And then there'll be a slightly abbreviated version, which is what I showed here, that would face the public. And so then there are a few other things that we're working on right now in terms of being able to filter the data and also optimizing for mobile, as I had mentioned. So with that, thank you. Please let me know if you have any questions. I really appreciate the opportunity to speak with you.
Yeah, I wanted to just add one thing. One of the reasons that we thought it was really important to put this together, when IHS started distributing the clean water to the various distribution sites during COVID, one of their concerns was they had a limited budget. And if people were picking up those water jugs and using them for all domestic use, they were going to blow the budget before the drinking water need was met. And so they were asking us if there was any way that we might be able to identify wells that were perfectly safe for other domestic use, like watering gardens or bathing or cleaning or things like that, that would preserve that drinking water resource for a longer period of time. And so we think a tool like this that could be available in chapters so that if people are still hauling water, and we have seen a huge drop in the number of people that are reporting that they're hauling water from unregulated wells, but still some. And if they are hauling, at least it would be a way of giving this tool to people so that they could direct chapter members to safer rather than more contaminated sources.
Right.
And these still don't contain bacterial data. These are just the metals data.
Exactly, yeah, just metals and chemistry. And that's really, I think, an effective, that's the data that exists for, for the last century.
This water that basically sampled, did this having it sit there that changed the water quality?
I don't know the answer to that. These records that are here are some that have already been sampled. So I'm actually not a water expert. I'm more of a mapping web.
So
but yeah.
I was just wondering how Miss Dr. Solsti's work and how your statistic interrelated.
Right. So these are kind of an aggregation of data. So there's definitely some built-in assumptions in all of this, right? So there are some wells that we have one observation and some where we have one every decade. And so what we did was we, tried our best to represent what would be a steady state in these wells based on just prior knowledge. But yeah, there are definitely assumptions that are built into that.
One thing that was interesting, because that's a question that Water Resources also asked us when we were very first starting the Dene project, is how we could make any kind of use of data. It's just one sampling point when the protocols for water quality are portable samples. And for the wells that we've had an opportunity to sample repeatedly or to get data that were sampled at different periods of time, there's actually a fair amount of stability. The values can change a little bit over time, but we infrequently would see a well that didn't meet standards jump up or jump down to be clean. Generally, relative to those standards that you were trying to judge the water quality on, wells tended to be either above or below. That's not 100% for sure, but that is something that in any particular region you can look at through the wells that we have multiple sources. And these data were collected from researchers, from government agencies, Water Resources worked with us to the extent that they have water quality data on these livestock wells. So, as this becomes a living tool and people can keep adding to it, one of the things we're dealing with now is also how to prioritize access, because some of these data, the data Dan referred to that can't be released were collected under IRB protocols. They were part of human research studies. And so, it's gonna take some thinking about who can have access to those and under what kinds of conditions. Certainly the intent is that those data get used to inform policy. And so then we have to talk about tiered access so that policymakers could have one tier of access and general public might have a different.
Right.
But, I think this is a huge first step, just getting this many wells together. 500 was a huge step, and we did that 3 years ago now, I think it was, or 4 years ago. And now to jump it from that to the number that we have in there now, because of getting more people on board, is a huge step.
Yeah, thank you. And I also will mention that, barring an event such as, like mediating the water and cleaning it, the water will actually, it seems to fit what we're seeing. If we look, for example, at the median water level at each agency, like our colleague Joe Hoover did in a paper he wrote in 2017, we find that those numbers that he calculated really kind of seem to match what we're seeing in other samples and like continued collection of wells. So yeah, I feel confident, that this isn't going to be particularly misleading.
And I think it provides, some guidance on if wells are going to be developed for public use. What are the best wells in a particular region to look at to improve the access, even if people are still hauling? And what might be possible to move into public water supplies versus others that are just not even necessary.
Okay. And on these wells that on the document that was sent, were they also from, let's say, windmills, livestock windmills?
Yes.
Okay.
Yeah, absolutely. So you can, they have every single, they have even, spigots at springs. So everything that we can think of where water could be consumed by, human, plant, or animal.
Yeah, I noticed that you had some data that's south of I-40, kind of like toward the Blue Water Village area.
Let's see, I'll go to a full.
Yeah, right there, those dark spots.
Yes.
There must be a lot of private wells there in that.
There are. Yeah, and so what we were able to do is in some instances be able to see what the intended use of the well was, or there's a better qualitative record saying, this is an old windmill, or this is that spring over that hill. But a lot of the times it's just
like
unknown.
Adjacent to the El Nolpai, what is it, National Park?
I think it's following the protocol. I think a lot of those data came from spill.
Right.
And some of the monitoring that was done after the spill, and then Tommy Rock and the people in Newlands and Sanders did a study that was funded by EPA for a while. So they gathered a lot of the data on water quality down there that was impacted by the spill in '79. So I think a lot of that sort of linear trend is related to that.
Yeah, and so the reason it's so.
So I'm kind of like, that's west of the state line.
Yeah.
Okay, so that's that's the area down south.
Correct, yeah.
Okay.
And the reason it looks so dark is twofold. I mean, there's just a lot of sampling there. And so at this level, it just kind of clusters. And then a lot of the intended uses are unknown. And those are just color coded as gray. Right? And so it just looks darker because we don't know what the use of those wells for all of them is.
And it would even be downstream from the Fort Wingate military. What used to be the Fort Wingate military reservation.
He said downstream from Fort Wingate. I actually,
That's a good question. Just trying to see, yeah, I'm trying to see where Fort Wingate would feed in there. Is it that kind of, that tan gap that's just east of the state line there? Is that where that would drain? Yeah, okay. Yeah, I don't know. We'd have to look and see what source we had for that, because we didn't get
Right.
any data from the military per se.
yeah, we have some from the USGS. There may be overlap, but yeah. Yeah, I don't doubt that. So one thing that you can do with this tool is zoom in on each one of those and click on that well, and it'll tell you, if we have that, it'll tell you, say who's the owner, who collected the sample. So as much information as we can get. So as soon as I get back to the actual tool, I'll click around and see what's there.
Be interesting to see if the Army would release their data.
It would
We
be.
didn't ask them.
You have a question?
Thank you. Just wondering about all those windmills on the reservation. And as I mentioned before, I know that the Navajo people used whatever water was available, even back to my childhood days, I remember home water. A wagon, that whole strong wagon, with barrels of that, loaded from the earthen dams. What? Now you see the windmills, sometimes you'll have writing on that for livestock use only.
Right. So
I was wondering, I know I was asked a question a while back, and I think I told the person that I would get the answer for them, but I never did, forgot about it.
Right.
But the question was, what makes it unusable? Those tanks that have for livestock use only, or supposedly for, it's not potable water. And if a person would have used it, what kind of effect does it have on a person?
Yeah, I'm probably in a better position
I-
to answer
yeah.
that than Daniel is. But what you're raising was a huge controversy back in 2000 when we started the Dene study. Those wells were put in for livestock use, and because they were livestock wells, they didn't have to be monitored for water quality. And since they weren't monitored, nobody was willing to take responsibility for them. And since there were so many thousands of them, it was way beyond anybody's budget or staffing to go out and figure out what the water quality was. And so I remember in 2000, when we started the Dene project and said we want to sample from the wells that people say they're drinking from, and everybody went crazy. And we ended up having a whole long meeting in the president's office with water resources and EPA and a whole bunch of communities from the Eastern Agency that were part of the study. And we had a long talk about, people are using these. We know people are using them. And sticking heads in the sand isn't going to help. We need to know what the quality is, and we can at least monitor these. And in the end, the community members made a commitment to water resources. That the fear at that time was, if we found contaminated wells, the community was going to push to have piped water distributed, and everybody knew that was not going to happen. And so the community said, no, we just want to know what the water quality is. And we will promise, we won't ask to have that water put in just because one of these wells is bad. But we also want you to promise that just because the water's bad, you're not gonna shut it down, because we still can use it for livestock and other uses besides drinking. But at least we're gonna know. And it was a long meeting. And in the end, everybody decided, yeah, it's better to go ahead. And I think that was the first time that sampling actually started. And this now is sort of a logical extension of that. What's happened in the meantime though is when we started that in 2000, everybody who was asking people where they were getting drinking water from, 75% of people they talked to were hauling water from regulated sources. And now, when we ask the younger generation where they're getting their water from, we have a handful of people, what is about 10%, who are hauling water, and most of the ones who are hauling from the water supplies. So the use of those wells has really shifted over time. And, you know, I think one of the things being able now to start pulling data together may offer us an alternative is additional sources that can be added to the public water supply system over time. Not having to have Conservation Water Resources pick up the tab to run around and start from square one and sample 2,000 miles.
Right.
So yeah, there's a long history, but yeah, basically it's that there were no data. So the easiest way to deal with that is to say nobody uses them. And it's still not a nation policy that they're not used for it.
Thank you very much.
I don't know. Should have made these a little more creatively. Why is this one so much bigger? Are you doing the PowerPoints? No. Are we doing PowerPoints or PDFs? Doesn't matter. It doesn't matter. Okay. All right. Ready? Yeah. Okay. Let me go ahead and this one first. Okay. All right, so I'm going to be fairly brief with this. I'm just going to give you an overview of one of our other centers that we have that is also addressing contamination issues on Navajo, as well as with some of our partners in Cheyenne River Sioux and Crow Nation. And this is a large collaborative study with partners from UNM, Montana State, Oklahoma State, as well as our community partners in, as I mentioned. So this is just a little map that reminds us where the different partnering communities are and illustrates the hash marks showing Native American reservations and overlap with mining areas. So some of these other communities also have concerns about mine waste exposures, and the opportunity that we have to look in these different communities with similar concerns allows us to address some of the commonalities and distinctions in both pathways of toxicants as well as effects, and understand
some of the toxicity and concerns in a more broad perspective. The latest, our second version, so we had we just got renewed for what we're calling phase 2 of our environmental health equity disparity center, is adding a little bit of a different perspective. So it's layering environmental concerns. We know that there's metals, and we know metals have some health concerns, but the communities are also concerned about some emerging toxicants. As Johnny mentioned earlier, trash burning and waste disposal infrastructure can be different in different communities. And there's different levels of infrastructure for managing waste disposal in different communities. And this can lead to these incomplete combustion from partial burning. So open dumping and incomplete low temperature burning of waste can lead to contaminants, microplastic generation, chemical release. And the composition of waste over the years has changed dramatically. If you think about all the plastic bags you bring home, all of the containers, we're no longer just burning paper and wood. There's so many other chemical components, and when they're burnt incompletely or near people's homes, people are concerned about what's that doing and what kind of contaminants is that putting into the environment. So we're starting to evaluate some of the secondary microplastics and chemicals that are released from these different burning styles, and whether people who live closer to these burning sites have more contamination, and what's the distribution in the communities of these contaminants. We're also interested in how microplastics and metals in the environment interact, because microplastics combine metals, so maybe this makes them more mobile, less mobile. These are things we want to know about. And it's important, since we're looking at the impacts of metals, we also need to understand whether some of these other contaminants are exacerbating some of these metal exposures. So those are some of the questions broadly that we're asking in this center. I have on the next slide the conceptual diagram. So we're looking at combinations of disparities in social determinants related to low income, education, infrastructure, lack of solid waste disposal, how all of these again contribute to environmental toxicants and contaminants. So we have one project that's looking mostly at the distribution in the environment. So looking for microplastics and chemicals in near and around the burning sites. And then we have one of the bio projects, and Dr. Yanlin will talk a little bit more of some of the components of that, where we're looking at some of the integrating some of this a little bit better and looking at health outcomes. So this is where the livestock and the health studies kind of merge, because we're going to be looking at livestock, where they go, what microplastics they are exposed to, what their trafficking patterns are. We also look at their chemical exposure. So we have these passive chemical detectors. They're little silicone wristbands like the Livestrong bands. Those can passively detect many different types of organic chemicals. So we will put those on the livestock and trace the livestock. And then we have a health component where we're also going to ask people who live in those communities to wear the wristband, so we can assess how much chemicals that they're exposed to. We can think about where they're going, and if they're going out to an area where there's known mine waste or other features. We're going to start layering and geospatially organizing toxicants and health effects to understand a more holistic picture of how all of these things are interacting, if that makes sense. And it'll make a little more sense when Jan talks about her geospatial analysis putting all these layers again together. So it's about layering in a way. And so the health studies will include, again, biomonitoring for metals, the chemical detection, health outcomes. So putting more layers of information onto what we have with the metals and the metal exposures. All of these, again, are going to be looked at in terms of overall immune outcomes, cancer, cardiovascular disease, other health disparities that we know in these communities, and see whether there are obvious associations or associations between types of contaminants and exposures within these populations. And looking at the 3 different communities will give us even more information about how these interact to affect health. So that's a lot of talking and a lot of pieces, and there's a lot of people involved in this project. We initiated this, we got funding to start this project about a month or 2 before COVID shut everything down. So we have not done a lot of analysis yet, but we're gearing up, and you'll be hearing a lot more about what we're finding in terms of the microplastics and the chemical exposures, health outcomes, and how all of this may or may not exacerbate or contribute to metal-induced toxicities as well. So it's a health-related project. Do you have any questions? I know I went through that kind of quick, and Leanne will talk a little bit more about the livestock, but livestock movement and livestock exposures are of concern to communities that rely on their local livestock for food. So this is also going to help address some of those questions.
I noticed that you had VOCs listed. Does that include methane?
I'm not sure if the bands detect methane or not. I will have to look at that. I honestly do not know, but I can find out and let you know. Okay. I know that they will pick up as many as 1,500 different chemicals. And I'm not sure about the methane.
Burn plastics. What kind of metals is that dispersed into the air?
So I know that there are some metals in plastic, and I don't know which, I don't know the answer to that. We were thinking more in terms of chemicals than metals from the plastic. But the microplastics may contain metal contaminants. So
you're talking about trash, when people dump the trash, they burn it. My neighbor has a big trash barrel over there. They dump the trash in all the time and burn it. Every now and then the wind picks up and comes towards my way, and you can really smell it. So you're over there trying to close all the windows and doors. In the summertime, you got to turn the air conditioner off and burn up a little bit. So I'm sure there was some contaminants that they're doing.
right, that's what we're going to try to assess, to see what kind of different. There's the local cans, there's the huge pits, and we don't really know what is being emitted from that that is adding to exposures. So we're going to map we're going to map where those are and where our participants are, and they will have the wristband so we can measure the chemicals. We will ask people to wear a wristband for 1 week in both summer and winter to kind of offset the season, so we can get a little bit better idea of chemical exposures. Have them have a diary so we know how much time they spent inside, how much outside, where they went, so that again we can map that and understand where and when chemical exposures are potentially occurring.
So when you burn trash, like there was an open pit, they were burning trash in there, and water gets in there, or there's a water stream that comes by, is that chemical actually go into the soil too when you burn trash?
It very well might, and we will analyze that, and we'll also be looking at the microplastics, so the small pieces of plastic. We'll be looking at how that's moving through not only from the site of burning, but into the soils and to the waters, as well as the plants. So plant uptake of microplastics is also a component of this. So again, how is it moving through the environment from burning to soil to water to plants? We can also look using excrement, I guess you could say, for exposure in people.
And also on Sioux, they're not doing as much burning, but they do there's a lot of open dumping that happens and a lot of open dumps that are managed, but they still erode and it can still break down in much the same way that mine waste into micro nanoparticles. This plastic waste can do the same thing if it's exposed to the air and the sun for a long time. So that'll let us also compare the differences. That photo from Crow is what actually got this all started, because they apparently have about 4 of those that are in the valley along the Bighorn. When they burn those, and that's being done by the tribe, it just sits in that population.
And it smolders for a long period of time, and so it's not, so it's this ongoing release, you know, and those are all of concern, and do that, you know, if the livestock are near there, are they picking more up, or so some of that, and help.
It's hard to train people to do their trash disposal, you know, because I keep telling my neighbors that you need to take it down and dump it somewhere else, but it didn't happen. Because I did that when my parents, I went to my parents' house, they used to all throw all their trash in the ditch and wear it all the time. When I moved there, I stopped all that. I tried to clean up that mess that was there. There's a ditch that runs through there. Water, it rains, water comes through there as well, so we're just kind of curious on that.
Yeah, those are questions that we don't really have a clear answer on. Those are some of the things we're going to start looking at through this center. So it's adding a little, again, another layer. Yes.
I guess what really during this pandemic year, what we've seen is water distribution includes 12 or 16 containers. And in our area, we see a whole bunch more being dumped into the rivers. And at some point in time, those things will just shoot them away.
Yeah,
End up in the Rio Grande.
Yeah, plastic contamination is a concern worldwide. I'm sure everybody's seeing a lot more in the news about plastics and, you know, straws ending up in wildlife. I mean, it's a major concern, not only in regards to pollution, but in regard to potential emerging toxin and health effects.
I think another thing that's really interesting about the work that they're planning to do, the community members have concerns in several places about livestock, not livestock,
wildlife.
And so there's an aspect of this that's going to be using those same bans in areas where people have traditionally hunted before, where they know livestock tend to congregate, wildlife tend to congregate, using those bans in those areas to assess what contamination.
Also sampling of stool from wildlife to see if it contains microplastics, just to get a sense again of how much, how broad that exposure might be. Okay, Dr. Lin.
Dr. Lin, I have 2 files. Which one is it? Okay, great. Yay.
Hi, sorry. Can everybody hear me?
Yeah.
So my name is Yan Ling. I'm from Department of Geography and Environmental Studies at UNM, and I'm also affiliated with Native Environmental Health Equity Center and the Superfund Center. So I'm very honored to give a brief summary of the livestock project in Cove community on behalf of the co-authors of this work, including Dr. Joe Hoover, Daniel Bean, Leo Liu, and Dr. Johnny Lewis. And this work has been supported by EPA and P50. So this is a collaborative project with Cove community members, Cove leadership, and research partner from Northern Arizona University, including Dr. Jenny Ingram's team in chemistry, DNA College, including Perry Charlie, Dr. Don Robinson, who is the overall project PI, and Neil Roy, as well as the Montana State University Billings, Dr. Joe Hoover's team, who started this project at UNM and then moved to Montana State University Billings later. The UNM team include Dr. Johnny Lewis, me, Daniel Bean, and master student Leo, as well as several undergraduate students intern. So why are we doing this study? So as you all know, Cove has over 50 abandoned uranium mines in the watershed. Livestock, including free-range cattle and the sheep, roam in the watershed and may come in contact with these mines. So for members of the Cove community, they are concerned about whether the contamination is hurting their livestock, as some of you already mentioned earlier, or whether it's safe to consume organ and meat from animals in this area. So the community have requested a study investigating the uraniums in livestock animals, including, and so in response to this request, researchers, we are working together with partners introduced in the previous slide. We're trying to investigate the human exposure to in livestock exposure and as a motivation of this work of this study. So working with the Cove community, we designed this project to investigate where livestock are grazing and how frequent and how long they're grazing near abandoned mine sites. So to do this, we offered some approaches on livestock movement tracking to the community and the livestock owners. And they decided to use GPS for data collection, and then we used the low-tech GPS colors shown in this picture to monitor the livestock movement. And these colors are lightweight and have a robust design, and the battery could last for more than 12 months of tracking. And these two pictures shows that Dr. Joe Hoover is coloring a sheep and a cattle. And this is a master student, Leo, who has been working on this project as his master's thesis. So after collecting the GPS data, we have thousands of data points because they are collected at every 15 minutes. And we mapped the grazing patterns with probability of information to account for uncertainties. And based on the grazing pattern, we then created a zone for environmental sampling for the Northern Arizona University team, who then collected environmental samples, including water, soil, and plants, to examine the uranium level in this environmental samples, and then to compare them against the non-mining area, including in the Red Valley area. So we then, based off this geospatial modeling, a geospatial modeling product with environmental exposure levels at every location in Cove community, based on how close they are to mines, meteorological information, terrain effects, and then we estimated the livestock cumulative exposure potential. And then, of course, we will compare this modeled exposure potential against the actual sampling data. And then the Northern Arizona University also examined the uranium level in tissue and organs from livestock and compare them versus non-mining area, which is the Red Valley area. Because of the pandemic, we haven't collect any data in the non-mining area, which is the Red Valley. But we will actually start doing this field work next month. So this is just an example map showing the livestock grazing pattern of one flock we colored, and the yellow polygons are the mine sites, and you'll see different colors show the grazing density. And you can see from this map that they're not grazing near the mine area. And they're in general 3 to 6 kilometers away from a mine site. So our preliminary geospatial analysis also estimated the cumulative exposure of the 2 flocks of sheep and goats we colored, as I mentioned earlier. And then the Northern Arizona University team did some preliminary data analysis based on 1 flock of livestock grazing area. Not for all of the livestock grazing area, because we haven't collected, they haven't collected all of the samples due to the pandemic. And then actually the preliminary analysis from the Northern Arizona University found that all of the water samples exceeds the US EPA drinking water standards. But all of the soil samples are well below the residential soil screening level. And the grass sample and a hay sample also show low uranium concentration at the background level. And other plants sample also show low levels of uranium, except a type of a plant. It's called a yellow sweet clover that has the highest uptake of uranium, which also tends to produce very quickly, presenting the possibility of rapid uptake of uranium from the water in the soil. In terms of the preliminary sheep and goats results, our 1 flock of livestock has low uranium concentration in tissue compared with other areas. And then the low uranium concentration also match with our geospatial findings based on their grazing area. And then the relatively low uranium concentration in our sample is likely due to the fact that this flock of livestock have been kept in the owner's corral and fed with hay from other places. And they're only out grazing when we color them for a short period of time and are far away from the mine sites. And in those areas, as I mentioned earlier, showed low level of uranium concentration in grass and the soil. And also this flock is also younger. And we have presented some of these preliminary findings in Cove chapter in February last year, just right before the pandemic. And we have not been in the field since the COVID, but we're resuming our field work this summer, starting next month. And some of the activities include identifying, and we're currently identifying livestock owners in Red Valley and Cove. And then also we will plan to do some field work to collect a plant, and then you will do some field work to collect a plant and soil samples in the new area. And then we will be coloring livestock, primarily Red Valley, but also a few in Cove. And then we will visit the livestock owners and then check color conditions after we put the colors on. And then for a few months, and then we will come back and then download the color data and then remove the colors. This is what Dab just mentioned, phase 2 of our Center for Native Environmental Health Equity Research. And so the overall design of the Cove Livestock Project is being applied to Blue Gap Tachi community, supported by this phase 2 of the P50 Center. Besides coloring sheep and goats with GPS color, as Dab mentioned, we will be also attaching a wristbands to collect other chemicals in the environment. So we're working to understand where sheep and goats graze in the Blue Gap Tachi community and measure the exposure to metals and other non-metal chemicals from other environment sources like trash burning, pesticide use. And we will likely use information about where animal graze to learn about livestock and human exposure in the community. So and this summer, we're currently working with the community to recruit livestock owners to participate. And then we have ordered brand new colors, which are ready to go. Hopefully we could put on the colors this summer as well. And also the last items on the agenda I mentioned and included in my presentation is, if I have a little bit time to briefly mention, a National Science Foundation project on tick-borne disease. And we are invited to submit a proposal to NSF to examine and understand the tick-borne disease pattern and dynamics, leveraging some big data. And we're discussing the possibility of doing something on Rocky Mountain spotted fever, which is a severe and potentially fatal tick-borne disease. And Rocky Mountain spotted fever cases have recently been identified in Arizona since 2003, which has not been previously seen. And American Indians have a higher average annual incidence of Rocky Mountain spotted fever compared with the overall US population. In past few years, we have also seen a significant increase in Navajo Nation because of the brown dog tick, which caused this disease in Arizona and the Navajo Nation. And it's often found on dogs and in and around people's house. And we're interested in the idea, just brainstorming some of the ideas of applying the same idea of GPS coloring to understand the tick population relative to dog movement. And we really want to know if anyone would be interested, and if so, which communities would be interested in this proposal. So I will be stopping here and happy to answer any questions. Thank you. Am I freezing? Sorry, wonder. Hello?
I can hear you.
I wonder if we lost a connection to them.
Can you hear us?
Yeah, I can hear you. I
We can hear you from remote, but you're right. You may have lost the
I'm
committee.
gonna text Deb.
Oh, really? So I might have to present again.
Those of us watching got full presentation.
Oh, they can hear no questions.
Oh, they can hear, but there's no question. Oh, okay.
Yeah.
Okay, thank you.
You're
But
welcome.
I cannot hear them.
No, we can't hear them, or I can't hear either. They hear us.
Thank you.
You're welcome.
Okay, well, it seems like, yeah, they might have lost audio connectivity. I'm across the street here at Stanford House. And next on the agenda, we had Thomas Dupree. Thomas, are you on?
I'm here,
Unless-
Carolyn.
I don't know if the committee is discussing something, so maybe we should give them a minute to see if they can either maybe type in the chat box or let us know what's going on.
You know, I don't see a chat box on my interface. I don't know if it's disabled and if others are experiencing that.
Notice that as well.
I don't see chat either.
Let's We'll wait a minute to see if we can get a response to see if we should just go forward.
Sure.
I'm hearing something faint from the main room, but we can't hear you.
So Thomas, Deb said you could go ahead and do your presentation if you would like.
Great. Thanks, Tamara. Yeah, I was just going to suggest that if they can hear us, I can just kind of go ahead if there are no questions for Lynn. Carolyn, do you have my slides or should I try to share my screen?
Why don't you try to share it? I do have a backup if we need.
Okay. I'm just going to pull them up. Bear with me. Okay, can folks on the call see the images that I'm sharing?
Yes.
Good.
Yes.
Excellent. Excellent. Thank you. Good afternoon, everyone. I'm just going to assume that you can hear me and see these slides for folks who are in the room. And thank you for giving me an opportunity to present on what I think is a really important issue. So my name is Thomas Dupree. I am a postdoc in the School of Medicine at UNM with a research training appointment in the Metals Superfund Research Center and a teaching appointment at in the Environmental Sciences program at Southwestern Indian Polytechnic Institute. And I'm going to give an update. This is not a project overview. This is just a brief update on issues happening in the San Mateo Creek Basin and Rio San Jose. This is not in the Navajo Nation proper. It is located near the southeastern checkerboard area and is part of broader Zinita, as indicated by Mount Taylor or Sutzil in the background of these photos. So I'm going to offer this as a precautionary story about what the federal government refers to as remediation of abandoned uranium mine lands and the problems associated with what are called alternative concentration limits, or ACLs. And so over the course of the last 3 years, the Department of Energy Legacy Management, DOE, has been giving annual tours of the Blue Water uranium mill tailing site, which they inherited in 1997 from Anaconda Mining Company. And these are a couple of the photos that I took during 2 tours of the site. This first slide, this is a photo of the Blue Water large tailings pile. This is the byproduct of uranium ore extracted from the Jackpile Pewati mine in Laguna Pueblo, which was once the world's largest open pit uranium mine. 99.9% of what was extracted from that mine remains on site here, leaving these massive man-made mesas. The Blue Water Disposal Cell, a term used by DOE, contains 23 million tons of tailings and other contaminated materials. It's about 354 acres around the base and about 100 feet high. This tailings pile is capped on top with a clay radon barrier and blue water basalt riprap erosion barrier, and that's what we're seeing here. The DOE legacy management took us on top of this tailings pile to demonstrate the effectiveness of the barrier and to show us that it's safe to be on the surface. But underneath, it is unlined, meaning there are scarce precautionary barriers between contaminated materials and precarious groundwater resources located underneath. I'm sorry, the precious groundwater resources located underneath the pile. In the second slide of this photo, we can see that legacy management is showing us the shape and concentration of a uranium, selenium, molybdenum groundwater plume leaving their site at 0.44 milligrams per liter for uranium and moving through the San Andres Glorieta aquifer toward the home state tailings pile and towards the Rio San Jose.
Excuse
So
me,
even though, yeah.
I'm so sorry. Can you speak louder? The people at the meeting can't hear you very well.
Okay, yes, I'll try and project my voice. Thank you for letting me know. So I'm referring to here a uranium selenium groundwater plume that the Department of Energy has rendered for us in this map. It's moving off site and it's leaving the DOE site at 0.44 milligrams per liter for uranium. The maximum contaminant level for uranium accepted by the EPA is 0.03 milligrams per liter for uranium. So this is a large order more than that. And so the plume is moving off site. And one reason that they were allowed to, one reason why the concentration of contaminants in this plume is 0.44 milligrams per liter as it leaves the site is due to this policy that I mentioned just a moment ago, alternate concentration limits. Companies can request this lenience from the government if they can demonstrate that it would not affect any populations, and there are a few other criteria for how they can get these alternate concentration limits. But the point that I want to make here is really about this precautionary tale that the Department of Energy Legacy Management perhaps should have never accepted this site, given the fact that it now has a uranium plume above the EPA's maximum contaminant levels moving towards the Rio San Jose. This year, the DOE did their tour virtually, and they actually gave that tour last week. My students and I attended the meeting, and we had a chance to ask a couple of questions. The question that we asked of the DOE is, have you identified the leading edge of the groundwater plume, or does that remain a data gap? And are you finding water from your site in the Rio San Jose, and what are the concentrations of contaminants? Their answer to that is deeply concerning. They have not found the leading edge of the plume, and they have not done research on the Rio San Jose and how their site may be affecting waters there. So I am bringing this up both as a precautionary story about what we should consider as remediation, and also to remind us that we need to contest these federal government agencies and their remediation projects and encourage them not to accept sites such as this one here. And so let me just end there. I'm not sure if I was loud enough for folks in the room to hear me. If there are questions, I'll take questions. And thank you very much again for giving me this opportunity to just bring up this really important issue that I hope we all can think about a little bit more.
This is Chris. I have a couple of questions, Thomas. Can you hear me?
Yeah, go ahead, Chris. Thanks.
Okay, using this picture here and their graphic, and I'm trying to use the magnifying glass to look at the scale. So the blue is a plume of uranium up to 0.03 micrograms per liter. Is that correct?
That's
Up
what
to
this
the
map
drinking water
shows.
standard.
That's correct, yes.
Okay. And then the green is up to 100 micrograms per liter, or 0.1, right?
That's right,
Okay.
yes.
So then where's the 0.44? Is that the orange or the red? I can't read the scale.
The 0.44 would be the orange.
Uh-huh.
And I should note that we had seen several different renderings of this tailings plume. The DOE produces these really rich images of their plume monitoring, but we need to note how limited their data actually is when they render these plumes. So there are a significant amount of data gaps, and you see the red dots indicate the wells that go into the San Andres Glorieta aquifer. And many of those are the wells that they're using to render this plume. However, there are many other wells that they could be using, and they could be using more recent data. Much of the data they're using to render this plume goes from 2013 onward. But I just want to make this point that I have seen many different versions of this plume, and it changes over time, and the DOE is portraying this plume in different ways. But do you have a question on that, Chris?
Yeah, I have just a couple of comments. Just to the right of the person's knuckle who is pointing, that looks to me like that's the homestake tailings pile, that kind of rectangular thing there. And as I attended the virtual meeting last week of this discussion, there are very few wells between the Blue Water site and the Homestake site to construct this map. But the misleading part of this map is that they use the colors blue and green to define, especially the green, as a level of contamination that is up to 3.3 times the drinking water standard, right? We often, when we choose to represent contamination on slides, we choose blue and green to identify concentrations that are below any standards. In other words, green is go, blue is cool, it's good. Yellow is caution, orange is even more caution, and red is contamination, right? And so this picture gives a misleading view, in my professional view, of the seriousness of the issue that you're raising here, which is the notion that we're essentially being asked to accept contamination from what used to be a privately owned facility that was taken over by the government through the DOE, and that's part of the Atomic Energy Act now. They can do that. But the DOE is going to be operating and taking over all the tailings piles in and around the Four Corners region, and already has them at Shiprock and Monument Valley, Mexican Hat, and Tuba City. And they will eventually take over the Church Rock mill tailing site. And if this is the kind of work that we're going to get in the future, you are absolutely correct that this is a major policy issue that is kind of being, I think, misrepresented.
Yeah, Chris, I absolutely agree. And, I really present this as a case of the Department of Energy should not be accepting sites as successfully remediated when they are indeed not. Successful in this case is not the appropriate word to describe the site that they inherited. And so I really want us to think carefully that in the future, if DOE gets their hands on sites, if legacy management inherits some of these sites, we want to make full well that they don't have plumes leaving the site that could be lethal to people or harmful to people living in the area. And those were the questions that were brought up by colleagues at the Multicultural Alliance for a Safe Environment and Laguna Acoma Coalition for a Safe Environment. Essentially, that the DOE should have never accepted something quite like this. And so as we think about other sites, as you mentioned, Chris, particularly in the Church Rock area, once the DOE gets these sites, they're often quite reluctant to do any remediation practices, although it does seem that that is within their mission and their purview. The Nuclear Regulatory Commission has written a letter to DOE to find the leading edge of this plume. It's not as if, you know, because their site is performing to standards, that they can just forget about the leading edge. And that's why it was so concerning to me that, you know, a year after the NRC wrote that letter, they still have not made an attempt to find the leading edge of this plume. But I agree with you, Chris. Thanks for raising those points. Happy to answer any more questions, and I can also stop my share if this image is no longer useful for us. Tomorrow, I'll rely on you to let us know what's going on in the main room.
Thank you. Chris, Johnny would like to ask you a question.
Yes, ma'am.
Sorry, I'm trying to get the question. Oh, if you could just have your phone ready, Johnny's gonna call you.
Hi, Johnny.
So apparently we are not able to hear them when they're talking.
Okay. All right. Why don't you stay on the phone and I'll speak to everybody. So hold on here. Okay, so everybody can hear me?
Yeah.
Thomas, you can hear me? So
yes.
First, so Johnny would like Thomas for me to summarize kind of what you said so that the others in the room can hear. They can see the image, right? So identify, first of all, the outline of the disposal cell in this graphic. Can you do that?
So let me share my screen. This slide is now someone else's share, so you can't see my pointer on it. And I can't share because whoever is sharing this screen, HEHSC admin is sharing. But if they just circle that red, red circle is basically underneath that blue water disposal, the large tailings pile.
All right, let me do these kind of one sentence at a time. So folks, the red oval in the middle of the tailings pile is the most concentrated slug of uranium. You'll see in the image a kind of a trapezoidal outline of what they call the disposal cell. So that is something of the property or license boundary. So the orange part of the plume and clearly yellow, green, and blue extend for literally 4 to 5 miles off of this site. The reason I know this is because I've been out there countless times. And you know, we've studied this place. So the point that the main point that Thomas is making here is that the Department of Energy, when it legally under the statute assumes control of these uranium mill tailing sites that have satisfied the NRC's reclamation requirements, then the government takes over the ownership of these sites and their long-term maintenance and in perpetuity, essentially. This was, you know, a way for the government to essentially subsidize the uranium milling industry when it went out of business in 1980s. So the government now is responsible for this pollution. And this pollution extending eastward intersects with plumes from the homestake site near where the man's knuckles are on the photo. And there was a question from the committee earlier. I think it was in the context of Daniel's presentation. This is off Navajo Nation. This is from Blue Water down to Milan and up towards San Mateo. We did not include wells and water quality data in the database that Daniel's working on, not because there aren't wells in here, they're just way outside of the Navajo Indian country. But I can tell you that throughout this area, there have been literally hundreds of private wells that have been abandoned because of contaminant plumes from both the Blue Water site and the homestake site. Many agricultural, livestock, and domestic wells for homeowners. It's almost like people who lived in the Milan area near Homestake, most of them don't live there anymore. Homestake, Barry Gold has bought them out. So this is the consequence. This is one example of the grave consequences of kind of ignoring or treating with less rigor these contaminant plumes under the ground. The first slide that Thomas shows a very nice cover on the Blue Water tailings pile, but you have to look under the ground to know what the real impact, and this impact is going to last for, potentially hundreds of years. Yes. Okay, so Thomas, they're asking, what are the aquifers that are affected by these plumes, and how close to Navajo communities are they? So correct me if I'm wrong, Thomas, but this line of wells at the kind of the southern portion of the yellow, those are all San Andreas Glorieta wells, correct?
That's right. And it's worth mentioning to them, Chris, about the intersecting fractures,
yeah,
the fault lines that are underneath the pile. It impacts all
Sure.
aquifers underneath, but they're representing the SAG. That's right, Chris.
Yeah, there's okay, so the regional aquifer that is right along I-40 extending southwest up toward the Zuni Mountains is called the San Andreas Glorieta Aquifer. It is the municipal water supply for much of the community and town of Milan and some of Grants. Obviously, the Diné people live in these communities, even if they are outside of the Navajo Nation. There is an alluvial aquifer that is associated with the ancestral flow of the Rio San Jose, which comes out of Blue Water Lake and flows through this area. And then there's the San Andreas Glorieta aquifer. Just to the east, where the man's knuckles are, there are 3 units of the Chinle Formation that are also contaminated by leakage from the Homestake Mill. The closest Navajo settlement is just to the northwest of this slide, farther west on I-40 at the Pruitt exit. So that's Baca Pruitt Haystack. Now, the groundwater flow for the committee's benefit is moving from the kind of the west-northwest to the south-southeast in this picture. Flows are also coming from the north into this area along the San Mateo Creek Basin. So to be, perfectly honest about it, groundwater flow is going away from where Navajo people live. But they have there are a number of mining and milling related contamination problems farther up I-40, especially along, for those of you who are familiar with it, County Road 19, which heads north from Pruitt up to Casamaro Lake. Okay, so there's a number of mines in that area. Then you go 10 miles north and you get to the Ambrosia Lake area, and we could spend an entire briefing just on the Ambrosia Lake contamination problems. Again, off of the Navajo Nation, but in some cases within Indian country, there are pockets of Navajo trust land. This is checkerboard. And so Navajo trust land is just to the north of the picture in the slide that the man is pointing to, or the person is pointing to. It's about another mile or so before you get to some of that Navajo trust land. So this is still a kind of a Navajo country. And of course, Mount Taylor would be to the east of this slide. And that's so this is one of the sacred peaks of the Diné people. For those of you who are remote, Johnny says that the committee is asking questions about kind of the long-term responsibility for all of these sites and how that may affect some of the policy issues that the Redwater Pond Road people are raising with respect to the removal of uranium waste, uranium mine waste from their community, and as a general matter from the whole Navajo Nation. And that is a very important policy issue. You can look at if we went north to the Ambrosia Lake area, you don't find clean groundwater. There's groundwater there, but it's all contaminated. There are two massive uranium mill tailings facilities there. There used to be 100 mines in that area. There are no more people. There are no more grazing. It is truly a national sacrifice area. But out of adversity comes opportunity. And it may be a place for a lot of the Eastern Agency uranium mine waste to be transferred to, provided, and this is the biggest issue in the room, that the federal government takes responsibility for the entire Navajo uranium legacy. It was the government that started this in 1942 and has really never accepted the burden of this massive remediation that is necessary throughout the Navajo Nation. We're just looking at one little quadrant of Navajo country that could be a place to take some of these wastes. But we'll need to have, as the Redwater Pond Road people pointed out, a Navajo Nation-led effort among stakeholders of various different jurisdictions, community groups, NGOs, universities, to really start rigorously looking at places to remove these mine wastes. And along with that committee is the vexing problem of how you transport the waste off of Navajo to someplace else, because it's always going to be in somebody's backyard, and those wastes are going to have to go through Navajo communities to get off of the Navajo Nation. It is. For those of you who are remotely, and Thomas in particular, Johnny's asking if anybody in the room there has any more questions for you.
Okay, great. And in the meantime, would you mind, or maybe it's worth conveying that each of these tailings piles, you know, are located near major hydrological resources, right? Because it took that amount of water to mill. So that all of these tailings piles that are, all of them unlined on the bottom, are situated in possibly the most precarious places in these environments. If you'd like to convey that, Chris,
Yeah,
I'll just add that.
Mr. Chairman Committee, Johnny, Thomas would like to make the comment that all of the tailings piles in and around the Navajo Nation in the checkerboard throughout the Four Corners were essentially developed back in the 50s, into the 60s and 70s. None of them have underground liners. When they were first designed, they were just piles of tailings put on the ground. They are all on major waterways. The Shiprock site and the Mexican Hat site are on the San Juan River. The Tuba City site is on Moncopi Wash. Of course, the Church Rock tailings is in a tributary to the Puerco River, which is a tributary to the Little Colorado River. So they're all on major sites. Like this one, the Church Rock site is not lined. It was never designed that way in 1974 and 75. So when we talk about remediating the tailings piles, the waste from processing of uranium ore, what you're seeing is the covering of the tailings themselves, and then the deferral of these long-term groundwater remediations to some further date, or as the Department of Energy described in the 1980s, a rule about natural flushing, which essentially said, if nobody's using the water, we'll let Mother Earth take care of herself. We'll just watch it. And no active remediation would take place. Well, can I tell them that we're releasing them from their remoteness? Okay, well, appreciate the committee coming, and it was a very valuable session. Yeah. Okay, folks, I think that they still can't hear us on remote, so I think they're going to wrap it up.
Got it. Thanks, Chris, for conveying that for me. I appreciate that a lot and adding details.
All right, well, I'm going to take off. I'll see you guys.
All right, see you, Chris. Bye, everyone.